Few years back when I was trying to learn AWS CloudFormation, I struggled with a good course that could expedite my learning as most courses were focused on theoretical concepts rather than hands-on. And my belief is that the best way to learn AWS CloudFormation as fast as possible is through hands-on. So this course, AWS CloudFormation Hands-On, is a full course for absolute beginners and intermediaries to advanced. You don't need any previous coding experience in any language or JSON YAML to go through the course. Let me just walk you through the structure of the course. In the section 1, which is the only theory course, we're going to go through the course introduction like this one, and then we're going to go through prerequisites, some basic terminology on AWS CloudFormation, and template anatomy. In part 2 of this course, we're going to focus on resources, parameters, and metadata. So we're going to create S3, EC2, and VPC using resources, parameters, and metadata, and then we're going to bring all of them together. So this is the most important section if you are trying to learn the CloudFormation from basics. In part 3, we're going to build an enterprise use case. You can see the architecture on your right. So we're going to create the launch configuration, auto scaling group, application load balancers, CloudWatch log group and SNS, CloudWatch alarm, hosted zones, and resource recording. And then we're going to do an end-to-end demo. In part 4, we're going to look at enterprise use case 2, and this is the architecture we're going to build as part of this use case. So we're going to create some VPCs, subnets, internet gateway, route table, routes, security group, and NACL. In part 5, we're going to launch the AWS CloudFormation using CI/CD pipeline. We're going to do an AWS CI/CD introduction. Then we're going to deploy the CloudFormation using AWS CI/CD pipeline with parameters and then without parameters. Then in section 6, we are going to look at other sections within AWS CloudFormation templates such as mappings, outputs, conditions, rules, and transform. So we're going to do a quick theory, and then we're going to do some hands-on in each of these sections. Finally, in part 7, we are going to look at other key concepts. So it's again more of a theory lecture. Hope you have a good learning experience and do provide the feedback. Thank you very much. Before we start learning CloudFormation, there are a few prerequisites that are required to go through this course. The first one is to have an AWS free tier account. AWS provides you with a free tier account for 12 months. In which a lot of services are available free of cost up to certain limit. So how you can set up an AWS free tier account, let me show you. Either you can go on this link or you can just Google. So let me just quickly show you. I'm on Google, so let me just search for AWS free tier account. Click on this, and you can see I'm on this web page showing AWS free tier. And it will tell you about some of the services that are free. So some services are available as free trials. Then few more services are available 12 months free. And then finally, some services are always free. So just click on this create a free account. Then you need to provide your details. So what is your root, user, email address? You need to provide the AWS account name, provide your credit card details, phone number, and then just follow through. It's a simple 5 or 6 step that you need to follow to be able to create the account. So once you have the account, this is what it's going to look like. So I already have the AWS account, so I won't be setting up a new account now. Next thing we need is the Microsoft Visual Studio Code Editor. So you can again download from this link, or you can go to the Google and search and then download. It makes it really easy to write the YAML or JSON files using this code editor. So let me just quickly show you. I'm on Google, so let me just search for Microsoft Visual Code Studio. You click on this link and then just go down, and then you can download based on whether you have Windows or Mac. Just click on this download Visual Studio, click on this Community 2022, it's free of cost, and once you click on this, it will automatically start the download. So I've already downloaded the Visual Studio, so I'm not going to do it here. If you face any issues, just send out a message to me. And once you have downloaded, this is what it's going to look like. So this is my code editor. Okay, the third thing that you need to know is have some basic knowledge of AWS services. So AWS services like S3, EC2, VPC, these you should have some basic knowledge to be able to create these services using the CloudFormation. Now what you don't need any previous coding experience. If you have no previous coding experience, is fine. It's not required for this course or for learning CloudFormation. Then finally, CloudFormation is written in YAML or JSON. And if you do not have any previous experience in YAML or JSON, that is perfectly fine. You will very quickly learn how to write these CloudFormation templates in YAML and JSON, even if you don't have any experience. I'll see you in the next lecture. Thank you. Fastest and easiest way to learn CloudFormation is through hands-on. But before we start doing the hands-on in this course, we need to know two things. One is the key terms that are used in CloudFormation parlance, and the second one is AWS CloudFormation template anatomy. So those are the two things we'll learn in this course before we move to hands-on. So CloudFormation is written either in YAML or JSON. They are basically simple human readable files used for writing the configuration. They are mainly written in key value pairs. So you can see here there are two files. One is the YAML and JSON. So we are trying to create an EC2 instance here, and all the properties for creating these EC2 instances are written in key value pair. So you have the image ID and then you provide the AMI value. You have the instance type, you provide what type of instance you are going to create. So based on this configuration, we will be able to create the EC2 stack. And there's also a particular syntax, and YAML and JSON is basically all about syntax. So you can see here how the spacing has been done. And this is what we'll discuss in more detail, but it's pretty straightforward. So there are a few data types that you need to know at a high level from YAML, and we'll see this when we do hands-on as well. So you have the strings, and strings here you can see you have the instance type, the value is a string, the key name, the value is string. Then you have the boolean. Sometimes say here you are trying to create an EBS volume and delete on termination. So you can have a boolean here, either true or false. Then we have the list. So here in this template, you can see you are trying to do the block device mapping, and here you have the list. When you are using a list, you will have another key pair mapping as part of the list, and we'll see this in more details later. Then you have the integer. So here you can see the volume size you are showing for EBS as 20. Then you have the pipe, which is used as part of the user data. So we'll discuss that later. I don't want to complicate things at this point of time. It's pretty straightforward. And then you have the floating point numbers, which probably you rarely use. So I just want to give you a high level for now. If you have not understood, it's fine. Once we go on to the hands-on, it'll be pretty clear. Now, what is a template? You will frequently hear the word template. A CloudFormation template is just a JSON or YAML file that you have written to create AWS resources. So rather than calling it a JSON or YAML file, we call it as a template in CloudFormation. So now what is a CloudFormation, or sometimes called as infrastructure as code? Is basically an AWS service that uses JSON or YAML template to automate the setup of AWS resources. So basically it's an AWS service where you will upload the JSON or YAML template that you have created, and then it will automatically create those services based on JSON or YAML. The last thing is stack. Okay, in AWS, all the resources are created as a single unit called a stack. So what does that mean? Say you are trying to create a 3-tier web app. Now you are not going to separately create services such as ELB, EC2 for web tier, then something for app tier, then something for database. So what you do is you create all the services for all the tiers in a single JSON file, and that is what is usually called as a stack. So in summary, you create all the resources that are required for your application as a single unit through one template, and that's what is called as a stack. Before we get started with hands-on, there's something important we need to know, and it is called as template anatomy. So this is a typical YAML template which has about 10 sections, and in these 10 sections there is only one section which is mandatory, called as resource. The rest, all the other sections are optional. So basically what I'm saying is that you can write the CloudFormation template with just the resource section, and you can eliminate or not use the rest of the 9 sections. So for the first few lectures, we're going to use only 3 sections. One is the version date, which is the CloudFormation version date. Second one is the description, which tells us a little bit about our CloudFormation template. And then resource section, through which we are going to create various AWS services like EC2, S3, etc. The rest of the section we are going to use as we move along. Now the question is, if only resource section is mandatory, why do we need rest of the sections? So let me give you an example. So here you can see we are trying to create an EC2 instance and we are hard coding the value of image ID. Now say this image ID is valid for US East region. But when I go ahead and run this template in Mumbai region, this CloudFormation template is not going to work. It's going to give an error. And the reason is because there's a different AMI ID for each region that you run the CloudFormation template in. So what you can do is you can use the mapping section, for example, where in the mapping section you will have that for this region, this is the AMI ID, for US East, this is the AMI ID, for Mumbai, this is the AMI ID. And when you run this CloudFormation template in a particular region, it will automatically detect the region and then use the corresponding AMI ID. Similarly, say you are trying to run this EC2 instance and you want to have some kind of a configuration where you use, when you are in dev, you use instance type as T2 micro, but when you run this in prod or other higher environments, then it should pick T2 large. So how you can do that is using the condition section, or you can also use parameters wherein you define that, okay, when I select the dev environment or when I select the product environment, this is the instance type that it should use. So this is where template anatomy and other sections are handy. You can also go ahead and do AWS CloudFormation anatomy if you do a search. So it will give you this, it will take you to this section. And you can see this is the AWS CloudFormation template anatomy. So you have YAML and you have all these sections and it gives you details, more details about these sections. So going ahead in the next few lectures, we're just going to copy this CloudFormation template anatomy and then modify based on our needs. Thank you. In the last lecture on template anatomy, we learned that there are 10 sections in a AWS CloudFormation template anatomy, and the only section that is not optional is the resource section, which is the most important section. So now let's take a look at what the resource section actually does. So as per AWS, the resource section is the required resource section declares the AWS resources that you want to include in the stack, such as Amazon EC2 instance or Amazon S3 bucket. So what resource section basically does is you actually declare the resource such as S3 EC2 VPC that you need to create and then provide its properties. So the resource declaration and its properties are defined in the resource section. Okay. So before we begin and start creating the resource such as S3, EC2 and VPC within the resource section, let's take a quick look at the anatomy of a resource. So here is the first thing, like if you look at the resources, so you have the resources keyword. So you define the resource keyword. Then below that you give some space and then you provide the logical ID. So what is a logical ID? So it is any ID that makes sense for the resource that you're trying to create. Say you are trying to create an S3 bucket for app tier. So you can name it as app tier bucket, or say you're trying to create a web server. So you're creating an EC2 instance for a web server. So you can name it as web server EC2 instance, something that makes sense. Then once you have the logical ID, then you provide some space and then you, from the documentation, you can look at the type. If you're trying to create an S3 bucket, then you will put it as AWS S3 bucket. Okay. And then you provide the properties. So what is the bucket name, tags, and any kind of configuration that you want. Now say if you're trying to create an EC2 instance, then you, instead of this, you are going to put the EC2 instance and the properties required to create the EC2 instance. So let me just show you a quick documentation on. Okay, I am on the AWS documentation and I will show you when we create the S3 bucket how to get to this documentation. But for now, I just want to show you here is a type when you're trying to create S3 bucket, and then you have the properties, and these are all the properties that you can define for creating this S3 bucket. Similarly, when you're trying to create an EC2 instance, so you define the type AWS EC2 instance, and then you define all the properties like host ID, image ID, instance profile, and you can define which ones are relevant to you. So again, a quick recap on the anatomy of resources. So you have the resource keyword, then you define the logical ID, which can be any logical name that you want to give to that particular resource. Then you define the type. You go to the documentation and look for the type. like we saw here for EC2 instance, and type for S3 bucket, and you can define the properties that are required. Okay, in the next few lectures, we are going to create S3, EC2 and VPC using the resource section. So one thing I just want to highlight is when you are running the CloudFormation stack, all the CloudFormation stacks that we're going to run in future lectures should be in US East 1. If it is not in the US East 1, then it might not work for you. So basically what I'm saying is that all the CloudFormation templates that we run, you should be cognizant that it should be run in US East 1. Thank you. Okay, now let's finally do some hands-on. So in this lecture, we're going to create S3 resource using the AWS CloudFormation. So what I've done is I have created this step-by-step guide, which would help us create any AWS service. In this lecture, we are going to follow only 3 sections from the template anatomy perspective. That is the format version, description, and resources. So now let's follow the step-by-step guide to create S3 service. So the first one is open the Visual Studio Editor, open new file, create a file name and save it in any folder. So I have opened the Visual Studio Editor. So let me click on file, new file. So let me call it resource and s3.yaml. And I need to save it now. So I'll just do a create file. And now let's look at the step 2. In the step 2, open and copy the template and anatomy to Visual Studio Code Editor from the following link. So I will just copy this link. Okay, so I have the template anatomy. I will go to YAML section and just copy, just paste it here. So as I said, we are going to use only 3 sections in this particular lecture. So I'll get rid of everything else other than resources, description, and template format version. Now let's see what are these things that are highlighted here now. So first you can see we have the 3 dots. So what basically it's just saying is that we are starting a new YAML template. Okay. The second one is the AWS template format version, which is the version of AWS CloudFormation template, and it remains same as 9 September 2010. So let me just copy it from here and let me just update this. Sometimes the apostrophes comes as reverse, so just make sure that you have it correct. Description. So now we can provide the description on what this template does. It's not mandatory, but it's good to have. So let's say this is the first CloudFormation template create S3. Okay, now we have the resource section. So before we start on the resource section, let's take a quick look at the anatomy of a resource section. Okay, in the previous lecture we had discussed. So the first thing we have is the resource keyword. So if I go to here, so you have the resource keyword. Let me get rid of this. Okay, so you have the resource keyword here. Then below this, what we need to have is a logical array, basically any name which highlights what we are trying to do. So let me just go back and let me just give some space and let me call it Rahul S3 bucket, and then I put a colon. Okay, now I give some space again, and the next thing you see is you have to search for S3 bucket as per documentation, the properties, the type and properties for S3. So what I'll do is, and if you even go to our step-by-step guide, so we've already provided the format version here. Then we have updated the description, and now we need to go to the resource documentation. So let me just go and let me search for AWS S3 CloudFormation, and it will just take us to the documentation. Okay, just scroll down to the YAML section. So now here you can see, just go here, and you have the type and properties, right? So I will just copy this from the YAML section. Remember, we are working on the YAML section and not JSON. So I just do a copy and I just give some space again, do a paste. So you can see here the type and properties are under the same subheading or the same indentation. So I'll just move properties under the type. Okay, so this is pretty much it. Now let's take a look at some of these attributes. What are the properties that we require? So if I click on accelerate configuration, so it basically does some transfer acceleration for Amazon S3 buckets. So is it required? You can look here. No, it's not required. Access control, you have the ACL. Is it required? It's not required. So you can see most of them, you will define whether it's required or not. If it's not required, then you can leave it as blank. So pretty much everything is not required, even the bucket name. And it might sound strange to you that even the bucket name is not required. If you don't provide the bucket name, AWS will by itself generate the bucket name. But for us, we'll just name the S3 bucket so that it just shows us how we're creating the S3 resource. So I will just get rid of pretty much everything else except the bucket name. And you can go through all the documentation. So I'll not go through all the documentation. If there's any specific attribute that you require, property that you require, you can add that. So I will get rid of the rest of the things. Okay, so get rid of these. So let's call this as demo 070. Okay, I'm just giving some random unique name. So this is pretty much it. I think we have everything we need. So we have the 3 dots signifying that it's a YAML file. Then we have the AWS template format version. This will always remain constant. You don't need to put it, but it's a good practice. Then you have the description. Again, it's optional, but we still provide what this template does. And then you have the resource keyword. Then you have the logical ID. Then you have the type properties from the documentation. Okay, let's do a save. Okay, now we can see now we have added the properties from the resource section. Now we need to go to AWS CloudFormation service and upload the template. One thing you need to remember is that you need, for all the next few lectures, you need to use the region US East, otherwise it's not going to work. Okay, so let me go to, now I'm on my AWS console. Let me do AWS CloudFormation. So here it is. Okay, now I will click on create stack, okay, and select template ready, specify the template. So I'm going to upload the template. So I click on upload the template, choose file, and select where you had saved that template. Okay, click on next, give a stack name. So you can say S3 bucket, click on next, and create stack. Okay, now you can see it is creating the S3 bucket. So you have the stack info, then you have the events where it's showing how the resource being getting created. And once it's completed, you can see the resource will be completed here. Okay, so you have the demo bucket 09070 that we had provided. Let's click on this and see if it's created. Okay, awesome. You can see that now this demo bucket 09070 is completed. Let's take a look at the stack. And it's showing as create complete. So let me just do a refresh. So here you can see as well, this is create complete. So our resource has been created. So let me just delete this resource so that we don't incur any charges. Thank you. Okay, in this lecture, we're going to create an EC2 instance using the AWS CloudFormation. So we're going to follow the same step-by-step guide and create 3 sections: format, version, description, and resource. So the first thing we're going to do is we're going to open the Visual Studio editor and create a new file. So what we'll do is we're going to keep the same template and create the S3 bucket, and on top of this, in the same template, we're going to create an additional EC2 instance. If you remember, this bucket has already been deleted because when we deleted the stack in the last lecture, it deleted this S3 bucket resource as well. So let me do is do save as, and we'll say resource S3 and EC2. Okay. Do a save. Let's update this description, this is the first CloudFormation template to create S3 bucket and EC2 instance. Okay, and now we have the resource section. Under that, if you remember, we have the logical ID, and then we have the type and properties of this S3 bucket. Okay, now the second thing is open and copy the template anatomy. So we have already done that. We don't need to do it this time because we already have the 3 sections: the format, version, description, and resources. Okay. Now I will go and search for the resource, right? So let me just go and open this and let me say AWS CloudFormation EC2. Okay, I'm going to open this. So you'll see on the left there are a lot of things that you have for AWS EC2. So we're going to go and search for EC2 instance, but that's what we are creating. And you can see if you go to YAML section, there are a lot of attributes that are defined here. Okay, we'll just use only the ones that we find are useful to us. Okay, so first of all, let's look at the anatomy that we have used previously as well, just as a review. So the first thing is we have the resource keyword, which is already here. Okay, now below that we need some logical ID. So let's the logical ID, and it should be under the same logical ID that we had for S3 bucket. So let me just go down and let's call it as Rahul EC2 instance colon, and then the next thing you can see is we have to put the type, like for here we had S3 bucket, now we have to search for the EC2 instance. So let me we just search for the documentation. So we have type EC2 instance here, and then you have the properties. So I'll just copy it from here and then just give some space. Okay, and it doesn't come out correctly, so we have to move the properties below type. And okay, so now we have pretty much both things here. So let's go to the documentation and let's study what are these properties. So if I just click on this additional info, so this property is reserved for internal use. So if you use this, the stack will fails with this error, so you can't use this. Okay, and is it required? No, so just skip it. Okay, now we have the affinity, so you can read through what affinity means. Is it required? No, so I'll just skip it. Availability zone, again, no. So you can see most of the properties are no. What we are going to look at is search for something that is useful and where it is required. So you have image ID required conditional, so we need to provide the image ID. And then what we'll also do is probably provide the instance type. So default is M1 small, so if you don't provide any value, it will take M1 small, but we'll try and use nano because it's free tier. Okay, so to get the image ID, this is tied to a region, so it will vary from region to region. Okay, so let's go to our console. Let me just go to my AWS console. Okay, so let me search for EC2. So if you have to get an AMI ID for our region is North Virginia, US East. So let me search for EC2 instance. So if you go to EC2 instance, say launch instance, and you can see here it provides you some details around the AMI ID. So this is one of the AMI IDs for Amazon Linux. So you can just copy it here. So it's just noted down here. And then we are also going to look at the instance type, right? Those are the two things we said we are going to look at. So instance type, let's search for nano, to nano. Okay, so I'll just copy it from here. So to nano, and you can also look it up here if you want. Instance type T2 micro. So micro is actually free tier eligible. You can use micro or nano, or let's use a micro. I think it's free tier eligible. So let me change it to micro. Okay, now I will go back to this and I will get rid of all the attributes except the two we have noted here. Okay, so let me get rid of all these things. So instance type, yeah, so that is, let me just copy it from here, instance type. Okay, if you're not understanding, you can just see here, this is the instance type. If I go or scroll up, okay, so here you can see this attribute instance type, which should be somewhere. So you can see here instance type and image ID. So those are two things we are going to use. Okay, so and then you have I will get rid of this. and then you have the image ID. So I'll just copy this. You need to be careful. The region that you run the CloudFormation, the AMID should be from the same region. Okay, I'll get rid of everything else. Okay, up to properties. Okay, so now we have two properties for this EC2 instance. One is the instance type and image ID, and you also have for the S3 bucket. Okay, so that's pretty much it. These two logical IDs should be under the same. So let me just move this as well a little bit. Okay, I think everything looks good. Let me just do a save and let's try and run it. So if you see the doc, our step-by-step guide, so the last thing is go and run it in the CloudFormation service. Create stack. Okay, template is ready. So you upload a template. So just choose a file, and we'll choose the file that we just created. Click next. Let's call it the resources. You can call it anything you want. S3 EC2. Okay, click on next. Click on next. Create stack. Okay, now let's see what happens. So I have the stack info here. Then you have the events. It's creating the logical ID resource S3 EC2. So if I do a refresh, now you can see it's creating a Rahul S3 bucket. This is the logical ID, and you have the EC2 instance. Let's see if it's creating any resources. So it's creating the demo S3 bucket and it's creating the Rahul EC2 instance. Okay, it's created the S3 bucket and it's still creating the EC2 instance. Okay, awesome. It's created the EC2 instance as well. So if I click on this, you will see that it will take me to the S3 bucket. Okay, and this is the name we had provided. If you see here, this is the name we had provided, and then it's also created the EC2 instance. Still coming up. But one thing you need to know, additionally you need to know, is logical ID. So logical ID, you can see here Rahul S3 bucket and Rahul EC2 instance. Logical ID is the name we gave here. It is used within the CloudFormation template to reference the services amongst each other. And then you have the physical ID. So physical ID is usually provided by AWS. So here in this case, in this EC2 instance, you can see this is the physical ID. If you go to EC2 instance, this is the value it will give. And similarly for even S3 bucket, it would have been provided by AWS, but since we specified it here itself, the physical ID, so it's generated the same physical ID that we had provided, but usually it is provided by AWS. So I will just delete this tag so that we don't incur any charges. Thank you. In this lecture, we are going to create VPC using AWS CloudFormation. So we're going to follow the same step-by-step guide. First thing we're going to do is open the Visual Studio Code Editor and then save this. Let's save it as new file, resources, and let's call it vpc.yaml. Okay, so we need to save it. So create file. Now let's look at the next step. So open and copy the template anatomy to Visual Studio Code. So let's do a search. AWS CloudFormation template anatomy. Okay, so open this one, go to YAML section and just copy this and go and paste it here. Okay, now as a third step, we have to change the format version. So just copy this and remember the apostrophe doesn't come out correct, so make sure you change it. And then description, so we'll add some description. So let's say this is a CloudFormation template to create AWS VPC. Okay, and like last two lectures, we're going to get rid of all the other sections except these three. So we'll just keep the resources. Okay, now I'm just going to get rid of this. So hopefully by now you remember the template anatomy for resources. If not, we'll just take a look. But step 3, we have changed this description. We provided description, and now let's take a look at the resource anatomy quickly once, and then we'll go to the documentation. Okay. So we have the resource keyword. So we already have the resource keyword here. Next thing is we have to provide the logical ID, right? So let's say Rahul VPC type and properties. So that we get from searching the documentation. So let me just go here and search for AWS CloudFormation, and we are trying to create a VPC. So we'll just search VPC. Okay. So you'll see it will come in this form of AWS EC2 VPC. And okay, you can see the YAML documentation here. So here are the properties. So you have the CIDR block, which you can define. Most commonly, you will use 10.0.0./16. Then is it required? Yeah, it's required. Then you have the enable DNS hostname. It's required. No, it's not required. You can read a little bit about what it does. Then enable DNS support. Again, it's not required. So you can go through all the attributes that are there. What I'll do is I'll just copy this and I'll go back. As per the documentation, I will just give some space between the logical ID and the type. Okay, so now I will move this to a little right. So that's it, it's under type. Okay, now we'll give the CIDR block values. So let it be /16. Okay, so this was mandatory. Then enable DNS hostname, as you could see here. It's a boolean, so let's give it as true. And then enable DNS support. Yeah, let it be true. And again, you can see it's a boolean, true. And we'll get rid of the rest of the things. Okay, tag. And then we have the tag. So tag is again always in the form of key value. So I would just write here, let's say name, let's say project, and then we'll say value, and value will be say banking. Okay, so that's pretty much it from the perspective of a resource section. So let me do a save, and if I go to our step-by-step guide, now we have already populated the resource section. Again, now we have to run the template going to AWS console, and please make sure that you run it in the US East region. Okay, so I'll go create stack, choose file, so we'll choose the VPC, and I'll select next. Let's give it name resource VPC. Maybe it can be pretty much anything you want. Okay, next, create stack. Okay, now let's see how it goes. So let's take a look at the resource. Okay, there is a rollback in progress. Let's see why it's failing. Properties validation for resource Rahul VPC with a message tags key not found. Okay, so something wrong with the tags. Okay, yeah, here is the error. Basically, it should not be name. It's always in the form of key value. Okay, so that's why this error. So we'll say name in the key, and then value as banking. Okay, so basically I just wanted to show you that there are going to be errors sometimes, and that's why I just mentioned the name incorrectly there. So what you need to do is you need to look at the events and see why it's failing. So now for now I have deleted this template and I will reload the template. So this is a very common thing, whether you're experienced at writing CloudFormation or you're just a beginner, you'll always see some template formatting errors, and it's not a problem. You can just go ahead and look at what is the error and try and fix that. Okay, I will go again to create stack and upload template, choose template, and let me choose this template again. Okay. So we'll say VPC, try to have a different name. Sometimes it can give an error if it's not deleted completely. So next, create stack. Hopefully it will work this time. So it's creating the resource, create in progress. Let's look at the events. Okay, so you can see create incomplete. Here also it's showing create as complete. Okay, so all the events are completed. Now let's click on this and it should take you to the VPC that we have just created. Okay, it should also have tag as the banking. So this is the banking. Okay, if I click on tags, you will see the name banking that we had mentioned here. Okay, great, awesome. So it works. Thank you very much. Okay, now let's go ahead and do some hands-on. In this section, what we are going to do is we're going to use the parameter section. So earlier we used format, version, description, resources. Now we're going to look at parameters and how to use that as part of the CloudFormation template. I have opened the template that we used earlier for creation of resources S3 and EC2. Now take a look here. So when we created the resources S3 bucket, so we had hard coded this demo bucket 0907. Similarly, when we looked at instance type or image ID, we hard coded these values. So this is not a good idea. What option we should have is when I load this CloudFormation template, I get a set of options, and then at that point of time I populate rather than hard coding these values, so that the template can be generic and then each team can use it as per their use. So I'm going to use the same template for writing the parameter section as well. So we'll leave it as it is, and I have upgraded this guide which will give us more steps that we had used earlier. Okay, so the first thing is open the Visual Studio Code editor and then change the file name. So I'll do save as, and I will say resources and parameters. Just do a save. Okay, now the second thing is you will see that AWS template format version, we already have it here because we are reusing the template from resources. Description, we can say I want to create S3 bucket in EC2 instances, parameters section. Okay, now we have the resources. We have already populated the resources, so we don't need to do anything. All we are going to do is parameterize some of the values for resources. Okay, so the next step is I will go to the parameter section and then add that section to this template. Just do AWS CloudFormation template anatomy. Okay, I go there. Okay, I've got it. So let me go to parameter section. So I'm in the parameter section. So I can either just copy this, or this is what the anatomy as we discussed earlier look like. So we'll just copy these parameters and I go and paste it. Parameter section would be at the same level as resource. So parameters. So if you saw this, if you remember the syntax, first thing we had the parameters keyword, then we had to provide the logical ID. Okay? So I have the parameters and now I'm going to provide. So what we're going to first do is we're going to provide this image ID. We're going to parameterize this image ID. So we're going to provide user with a few options that he can choose from. Okay, so let's call it as EC2 AMI ID. Okay, so this is our logical ID. Then type. So type would be string. So what you can do is you can just go to this documentation here and you can see for parameters instance type, you have the type as string. Okay, so let me call the type as string. And now you have the option of say if you're trying to create a default. So what is the default value that AMI should have, so the user doesn't have to enter allowed values. So you'll have all these drop down. So you have all these properties here that you can follow along and look for. So if your default, it's not required, but you can provide a default value. Similarly, you can provide a description. So what I will do is I will just copy this from here and then I will just modify it. So I already have till type. Okay, and remember these are the only three things that are required. The rest of are optional. So this said, so default we'll have to put some AMI ID and then we have to provide some AMI allowed values. So that would come as a drop down. So let's go to the console. Okay, I'm on the AWS console. So here I'm on the VP section. Let me go to EC2. Okay, and launch instance. Let's look for a couple of AMI IDs. So this is one AMI ID for Amazon Linux, and I will provide that as default. So if the user doesn't select any value, this is the value it's going to take. Okay. Now let's get one more. We'll also provide this as part of the drop down. So you will see that allowed values would show as a drop down. So let's say I put this one from Microsoft. So this is the AMI ID. One thing you need to make sure that the where you're going to run the CloudFormation template, that has to be same region as where you're taking the AMI ID. So, and enter the description, enter the AMI ID. Okay, awesome. So now I have added this AMI ID. Now what we need to do is we need to know one more thing. So something known as intrinsic function, and intrinsic function specifically ref. So in what are intrinsic functions? Intrinsic functions provide several built-in functions that help you manage the CloudFormation stack. And one of the most important is ref or reference function. So what a ref does is, see, earlier we had hard coded when we are creating the resource S3 bucket, we had hard coded this value here, right? But that's not what we want. We want the user to be able to input that value at runtime when we load the CloudFormation template in the AWS CloudFormation service, right? So how do we relate the resource that we are creating with the value that user has input? So you can see here what you do is when we under the parameter section, we create this logical ID and we allow the user to input this value. So user is going to input some value here, and then what is going to happen is when the AWS starts creating the resource, it will use this ref keyword. So instead of the bucket name, you use this ref keyword and then put the logical ID. So S3 bucket name is the logical ID here. You put that logical ID here, and then it should be able to take that value. Okay. So that's how you relate what the user is inputting and what is getting created. Okay. Now, so what we are going to do is instead of this image ID, we are going to use the ref keyword. So we'll say ref and then take the logical ID of that particular parameter from here. So I do Control C and I do the AMI ID. Okay. Now the next thing we are going to do is we are going to also provide options for the instance type. We're going to parameterize that as well. So I will go back to the documentation. So you can just pretty much use the same documentation, just copy from here and okay, I don't need the parameter keyword. So now first thing, if you remember what we used to do is first we provide the logical ID. So logical ID is instance type parameter. So we are trying to provide the user with the option for him to select the instance type at runtime. Okay. So this is my logical ID. And then you have the type, like here in this here case is again string. Default value will just put as a T2 micro. And then you have the allowed value. So these will again show as a drop down. And then you have the description. Now what we have to do is we have to link this logical ID, the user input that we are going to get, with this resource EC2 instance that is getting created. So I will again do ref and copy this logical ID. Okay, so I think this should work. Now the last thing that we're going to parameterize is this bucket name. We don't want this bucket name to be hard coded. So what you will do is you are going to parameterize that as well. So I will just copy the same thing, the same syntax. It's pretty much the same syntax that you will use most of the time. So you can just go ahead and copy it from the documentation. Okay, I'll move it like one step left. So we'll call it S3 bucket name default parameter. So type is again string. Default, there is no default because we don't want to put a default. S3 bucket name has to be globally unique. So you don't want the user to use the same bucket name because it's going to fail. So you're going to get rid of this. Allowed values also, we don't want to provide 2 or 3 allowed values because it has to be, as I said, globally unique. So we can get rid of all this. So one thing you need to remember is there are only 2 things that you need for creating the parameter. One is the logical ID and type. The rest It's all optional. Okay. And now we need to relate what the user is going to input with the value that we are going to create here. So we could do again useref and then use this name. Okay, let me move to the left. Okay. So type, it has, you need some space. Okay. So now I think this looks pretty good. So we have parameterized the image ID, the type, instance type, and the bucket name. So you'll see how when we load this on the CloudFormation service, we are going to get options or parameters to select from. So I'll do a save. Okay, I think I made a mistake. Okay, so I think the only thing I see here is that I don't think this AMI ID is complete. Let me just take a look. So, okay, so Microsoft, this was the AMI ID. I think I will just miss some piece of it. Okay. We can also additionally add description. So it will then tell the user what is it that he is trying to input. Okay, for in this case, obviously it's clear, but in some cases, it might not be clear to the user what is the expected values. So enter the AMI ID. Okay, let me do the save. And I think this looks good now. Okay, create stack, upload, choose file. Okay, choose this one. Okay, next. Meters and resources. Okay, I don't think there should be any spacing. Okay, now you can see we have another additional section which was not there earlier called as parameters, and it has three options. The first one is EC2 AMI ID, and if you go here, you see here the parameters. Under you have the EC2 AMI ID, which is which would have this as default value EEC, and then it should have two options and the description enter AMI ID. You can see here, this is the logical ID, enter AMI ID is the description that we had provided, and this is the default value, but it gives you two options. Then the second one, instance type parameter. So we have the second logical instance type parameter, and you have the default as T2 micro, and then you have 3 as part of dropdown, and in the description you have enter the which instance type we want to use. Okay. So you have the instance type, this is the description, and this is my logical ID, and you have 3 options, and the default one is T2 micro. Then finally we have the third one, which is the S3 bucket name P, which is our logical ID. So you can see here, because we didn't add any default allowed values, it just shows as a plain text box. Okay, so we'll give it some name. 30070987. We have to give a unique name. So go next. Create stack. Okay, so it's creating the stack. You can see it's creating the EC2 instance and S3 bucket as well. Okay, it's created the S3 bucket. Okay, you can see the S3 bucket has been created. Okay, even the EC2 instance has been created. So this stack is complete. You can see the EC2 instance running here. And the interesting thing is that you can see if you go to parameter section, it will give you the parameters that you have input. Earlier, this was not here when we were just using the resource section. So this is the AMI ID, this is the instance type parameter that you have selected, and the bucket name. Okay. So one thing you need to make sure again is run it in the US East, and if you have AMI ID, that should be selected from the same region. Otherwise it's going to fail. Thank you very much. In the last section, we looked at how we can create various AWS services like S3, EC2 using the resource section. Now in this lecture, we're going to look at another section called parameters. AWS defines parameters as optional parameters section to customize your template. Parameters enable you to input custom values to your template each time you create an update stack. First of all, what it means is that the parameters section is optional. It's not mandatory like resources. The second thing is, if you remember when we were trying to create an S3 bucket or EC2 instance in the last few lectures, we hard coded the values. So we hard coded the bucket name, we hard coded what kind of EC2 instance it should be, whether it should be T2 nano, micro, what should be the AMI ID. But a lot of times in large organizations, what happens is for standard tag creation, say like a 3-tier application, you'll create a CloudFormation template, or cloud engineering team is going to create a CloudFormation template, and then various teams, various application teams can use that CloudFormation template and provide the values, say for S3 bucket or EC2 instance type at runtime. So basically what you do is you have your CloudFormation template, it's a generic template, no hard-coded values. You upload it in the AWS CloudFormation service like we do. And then we, at that point of time, we provide what are the values we need. So it helps you to input the values at runtime. Okay, now let's take a look at the syntax for parameters. So first you have the parameters keyword like you had for resources. Then you provide the logical ID, anything that makes sense for the template. So here we are trying to provide the user with an option to select any instance type. So that's why I said instance type parameter Rahul EC2. So you provide the logical ID. Then you just go to the documentation and look at the type. So whether it's a string or any other type, and this you can get from the documentation. So these three are the mandatory things that you need to provide. Then what you can also do is you can have define certain property values, say trying to create multiple services, and user has to input for each service, user has to input the value, say he has to input what is the EC2 instant type, what is the AMI ID, what is the S3 bucket. So you can get a very long list. So sometimes what you can do is you can provide a default value, and if user wants, he can use the same default value or he can change it. Then the other option is you can also have a drop down. So when you put allowed values, you can provide your options, and then it will show as a drop down to the user when he loads the template on the CloudFormation service. And then you can also provide description, you can enter what are these options that you're providing. So this is basically what the syntax would look like. You have the parameters, then you have the logical ID, then you have the data type, and then you have the optional parameter value type. So I'll just quickly show you what are the options that you have. So okay, I'm on the AWS CloudFormation page on the parameter section. So you can see this is what the structure looks like. And then for the parameter property value, you have all these options. So you have the allowed pattern, you have the allowed values. I just showed you the allowed values here, T2 micro, T2 small, etc. Then you have the constraint and description, and this is the description I was talking about, what are those values. So all these options you can have it here. Okay, and the data type we're discussing, so you have the string, number, list, etc. So this is basically a brief on what parameter section do, and let's do a quick hands-on. In the previous lecture we looked at something known as parameters. In this section we're going to look at metadata, especially the interface part. So last time when we were creating the S3 resource and the EC2, we parameterize certain value like the bucket name, the EC2 instance type. Now we just had 2 or 3 parameters to where the user could input his values. But imagine you're creating a full stack, say a 3-tier web application. You could have 10 to 20 resources or more. And then for each resource, you could have 2 or 3 parameters. Then essentially you are looking at 20 to 30 parameter values which the user is going to input. Sometimes the good idea would be to all the parameters into some logical sections and then you input the value. Or more importantly, if you're changing these values later on and you want to change the subnet ID, so you could just go to, maybe we have a network section, storage section, then we have the compute section. So you quickly scroll up to the network section and then just figure out and change the value. So let me just quickly show you what I mean. And show this card. Let me go to my CloudFormation template. And this is the one which we had created earlier with the parameters. So you can see we had 2 parameters, the bucket name and the value for EC2 instance type, right? And let me just run this CloudFormation stack. Choose the file. So I'll select this one. The next data EC2. So let me just name it. Now you can see we have 2 parameter section. We have 2 parameters. We have the EC2 instance parameter and S3 bucket name, right? Now imagine if you have a larger stack, you could have 20-30 parameters. So what we can do is we can categorize these parameters into 3 or 4 subsections, like say networking. So everything related to VPC, subnet, routing table could be under the network configuration. Then storage S3 buckets, anything else related to storage, database, that could be part of the storage. And then you have the compute, you could have Lambda functions, containers, anything that does compute could be under the network, compute, and storage section. Okay, now let's go ahead and look at the syntax for metadata. So here we have the syntax. So first you have the metadata here. So you have the metadata keyword. Then next you can say type, you will have AWS CloudFormation interface. You just need to copy that. Then you have to define the parameter group. So it could be a network configuration group or compute configuration or storage configuration. Then if there are multiple labels, so it's a list, so you put this dash. Then here you have the label. In the label, you under that you can have default, where you put what is the kind of label that you want. So you could have network configuration, compute, etc., like we have compute here. And then you have the parameters which you want to include. Say for EC2 instance, if you have EC2 instance as part of the compute, and one of the parameters that we have is instance type parameter. So you can have that. Second, maybe you want to have the AMI ID as well. So you put here and then you put the AMI ID. Similarly, next, say it could be that you have the label, keyword label, then you have the default, and you put what you want as the label. So you could be storage, and then you have all the parameters that you have as part of the storage. So if you have S3 bucket, then you have S3 bucket name. Say the second one could be database. So under the database, you will just put all the parameters that you want to include. And the third one, I've just put the tags here. So you can parameterize the tags as well. What are the tags that are going to be used as part of all these resources? Here is the AWS syntax. So again, you have the metadata, and you have the interface, and then you just write the parameter group here. And under the parameter group, then you put the label, you put the default name, and then you put all the parameters that are going to be part of this parameter group. So now let's just go to this documentation quickly. So I'm going to open the link that I had shared just to quickly show you what are the properties. You have metadata, then you have this interface, then you have the parameters group, which you keep it as it is. Then under the parameter group, you could have different properties as it's shown here. So you have the label and you have the network configuration. Okay, let's just quickly test this out. So I will go to my stack. I will use the one which we had created earlier using S3 and EC2. So let me do a save as, and I will say resource parameters and meta. Okay. So let's go back to this. So I've just created the step guide, which is version 3, which includes the metadata as well now. Okay, we follow the same structure that we had till parameters. Now let's go to this link which I had just opened. I'll just copy this metadata section and just paste it on the top, because you can see now. Let me just open the CloudFormation anatomy. Okay, so here you have the format version, description, and then you have the metadata. So that's where we're going to put the metadata section. Let me just put it down here. So now we have the metadata. So we'll keep this CloudFormation interface as we discussed. Then we have the parameters group. We'll keep it as it is. Then we have the label. Okay, so we don't have any network configuration here. So I will just get rid of this section. It can be a list. So I just put this line here, and then a label. We'll just put sections. One, the compute configuration and storage, because we only have compute and storage. So let me name it as compute configuration. You can name it anything you want. Now, what are the parameters that we want to include under the compute configuration? So compute, we only have, if you can see here, we only have the EC2 instance. And for EC2 instance, what were the parameters that we had? The only one parameter we had was this. What was this? The logical ID of this parameter. So I just copy it from here, and then I just paste it here. Okay, and I get rid of this. Now the second one that we had, let's go to get rid of this, is going to be for the storage. And I do copy and control V. Okay, I just need it to be under the same column number. So I'll do a shift tab so that it moves back. Okay, now this and this are under the same, I need to push the label to the little right and default again to the right. Parameter should be under the label and this should move a little ahead. Okay, I'm just trying to organize it in the way it is in the documentation. So label should be under the same column. Okay, now let's name this as storage because we have the S3 bucket. And what was the parameter under storage bucket? So we have the S3 bucket, and the only parameter that we had was the S3 bucket name. Okay, so I need to put it here because on that it's already here. Okay, I'm just going to remove just the blank spaces. So now we should have, when we run the CloudFormation template and it provides us parameters, it should be under two subheadings, the storage and compute. Okay. Now, awesome. I think it's all good. So let me do a save. And let's try and run this, the previous one. Create a stack. And okay, now you can see the same stream that we are running. It has two types. One is the compute configuration where we'll have the EC2 parameters value. Then you have the storage under which you have the S3 bucket name. Now you might think, okay, what's the value of this? But because we only had two parameters, but if we had 20, 30, 50 parameters, then classifying these would have made a lot more sense. And when we go ahead and create larger stacks, then you will see the value. For now, this is how it's going to look like. So let me just run this CloudFormation template stack. Okay, so it's running. So now we have the parameters, which two parameters that we provided, and then you have the output. Okay, we have an error. I think we do not provide the parameter value, so you cannot create the stack. Let's just go back. Let me just delete this stack. Let me go to CloudFormation, create stack. Okay, next metadata S3 EC2. Okay, now we will give this value as micro is okay. Let me call it as S3000785. So just you have to give a unique name, otherwise it's not going to run. Let me try and run. Okay, so it's running the stack. You can see the resources that are getting created, the EC2 instance and the S3 bucket, and you can see the parameter input that we have provided. Okay, the S3 bucket has been created. Let's look at the resources. EC2 is just still getting created. So this till the time being. So you have the Rahuls and the random value that we had given. Similarly, EC2 instance. Let's see what's going on with the EC2 instance. Okay, you can see the EC2 instance is getting created, so it's still initializing. So I hope now metadata interface is clear to you and what is the use. In the previous lectures, we've learned a lot of different things. So we looked at what our template anatomy looks like. Then we looked at the format version, we looked at description, then we looked at how to create various AWS resources using the research section. Then we looked at the parameters and metadata. Now, in this lecture, what I wanted to do was bring all these together and show you how we can create all these resources as part of a single stack. Now, in this lecture, what we'll do is we'll create a VPC, then we'll create a subnet, public subnet as part of this VPC. We'll launch an EC2 instance in this public subnet, and then we'll create an S3 bucket. So how do we go about this? We'll create all these 5 subsections as part of the template anatomy in the resources. We'll first create the VPC, then we'll create the subnet, EC2 and S3. Then some of these values will parameterize VPC and subnet. Will allow the user to enter the VPC CIDR block and subnet CIDR block when we run the template. And similarly, we'll ask for user input for EC2 AMI, instance type, and S3 bucket. And then finally, we'll create 3 sections as part of the metadata: network, compute, and storage. And VPC and subnet will have as part of the network, the EC2 as part of compute, and S3 as part of storage configuration. Okay, so let's get going. So I will use this 8 steps that we usually use to create this template. So the first step is go to the visual editor, create a file. So I'll just create a file, create a new file. Let me name it as VPC EC2 S3 all together one. Okay, so .yaml. So let me go to the second step, which is open and copy the template natively. So I'll just go to this link, and I think I already have it open. So I will just go scroll down to YAML section, copy this, and go back to my editor, do a paste. Some of the things will remove. So like output will not done till now, transform conditions, mapping rules. Get rid of this. Now we'll go and check the version date. So I'll just copy the version date from here. Okay, so just make sure if you're copying from this PPT, sometimes inverted comma doesn't come out correct. So just remove this and put it correctly. Let me do is save. In the description, we can say create EC2 S3 VPC subnet along with metadata parameters and resources. Okay, awesome. Now we can start from either metadata parameters or resources if you know what we're going to create, but I just prefer to create the resources first. It just gives me an idea. So I will just get rid of this. Okay, if you remember from the previous section, let's go to the VPC, search for resources VPC. Okay, so VPC AWS CloudFormation. Okay, I get this one. Okay, so now I have the VPC. So if you remember the syntax, if you don't, just go to some of the previous slides. Here's the resource. So we have the resource keyword, then we have the logical ID, any name you can give, and then you just copy the type and all the parameters that you require. And the first thing we have to do is we have to put in the logical ID, right? So let me call it Rahul VPC. We call it Rahul VPC R, and then just let's give a space. And I go back to the documentation, and I will just copy everything from here, and I'll just paste it here. So I will just push this whole thing a little to the right. Okay, great. I think it should be with the type. So let me just get back. Okay, awesome. I think this is good now. So let's look at various sections. So we have the first one we have here, and put the CIDR block value here. So we can put it 10.0.0.0/60. So enable DNS host name, it's not required. You can see the CIDR was conditional. If you want, you can put true. Maybe you can put true. And yeah, let me just put it true as well. True, and I'll just get rid of these. Okay, now we have the tags. Okay, so let's put the tags. So let's put it as G and name, value, banking. So let's just, instead of the name, let's just call it like projects. All the resources we'll create, we'll name them as project and banking. Now let me do a save. Okay, now we have created the VPC. Then the next thing we have to create is going to be the subnet. First, CloudFormation subnet. Okay, so here it is. So as you can do, so copy Rahul. Rahul subnet R, and then I just, the value is type. So I moved here. Okay, we can get rid of this, whether you need availability zone ID. No, I don't need that. So I will just get rid of these three properties. Just give it 0.1.0 /24 so that it becomes part of the VPC. Does enable DNS, enable IPv6 side of block, map to public outpost DNS. So I'm going to I think just create a simple subnet, and then you have, again, I'll just copy the tags from here. So just keep the same tags. Key and value need to be under the same indentation, so I just move a little bit here. Now what you can see here is that it also requires a VPC ID, and let's read what is that. So it is required, yes, and the ID of the VPC is the subnet is in. So we have to refer to that value. Okay, so how do we refer to that value? Let me just first bring it under the same indentation. So it should be under the, let's see where it is required to be. So it should be under the tags, same as tags. This is a property. Okay. Here we can use, we learned about the ref keyword, reference keyword. So we'll do ref, and it will take the, and then we put the logical ID. So now you should know why we are putting logical ID, because it can be used within the template to refer other resources. Okay, now let's create the other resources, which is the EC2 and the S3 bucket. So let's first create the S3 bucket. Now let's name it as Rahul S3 and let's call it R. Okay, I'm just trying to give it a unique name. And then we have to go to the documentation again and search for S3 bucket. So I'll just search here S3. Okay, now we are on the documentation page for S3. So I'll just copy this and go here and just paste it. So I'll just get rid of most of the things other than the bucket name and tags. Okay, so it's gone. And all this is gone. Let's make it back. It should be in the same level. So type and properties. I think the type and properties should be at the same indentation level. Okay, so I know we're going to substitute this bucket name from the parameters, but let's just give a name for now. I'm just giving a unique name, and then for the tags, we'll just use the same tags so that we know it is part of the same stack. Okay, just move back. Okay, now we have the S3 bucket as well. Do the final thing and create the. So I'll just search for the documentation and let me call it as EC2. So there are a lot of things for EC2. So we need to look at EC2 instance, right? I'll just copy from here, go here, and first thing we need to do is give the logical ID. So let it call as Rahul EC2 R. Okay, R just for resource. You can give it anything you want. Just type. I'll just get rid of most of the things except tags and maybe a couple of things. So if you remember last time when we had created the image ID and instance type, I think where was required as mandatory. So I'll just get rid of everything else here. This is here. Let me just push it a little back. Okay, let's look at the documentation. So if you look at the documentation, see most of the things for EC2 instance are known, except if you see all these are known. So image ID, you can see it's conditional. So we need to provide the image ID. Let's go and search for some image ID. So this is the one which we had used earlier. So launch an instance. Okay, here is the AMI ID. So I'll just copy it from here. Look at here, and here we can put t2.micro We just get rid of this and choose file. This one. Let's do next. I think it seems okay, so let's just continue on that. Now let's add those two sections which I deleted. We have to add some parameters. So what is the syntax for parameters? Let's take a quick look. Okay, here we have the parameters. So you have the parameters keyword. So we already have the parameters keyword. Let me get rid of this. The next one is to give logical ID that particular parameter. Okay, so let me give a logical ID. So we'll say S3 bucket name, and we just call it P. Okay, and let's look at the syntax. Let's go to this CloudFormation anatomy where we should get the syntax for parameters. So here you can see all what the syntax looks like. So you have the parameter logical, you have the parameter, then you have the parameter logical ID, and then you have the type data type. So I will just copy this, and then you have the data type. Data type would be string, is okay, and then you have the parameter value, right? If you see here, you could have the default, you could have allowed values, you could have description, but for S3, as we had discussed earlier, we don't want to put any default values, or we don't want to give any allowed values, because S3 bucket has to be unique. So we just don't need this. We'll just get rid of this. Okay. Now the next thing we need is EC2. So what are the parameters that we can use here? So we'll do the image ID and instance type. Image, you can call it actually anything. So let me call it P, and we just copy this thing right from, so copy from here. Okay, so we'll give some space. Okay, so here's an example that you can see, right? So we have the type, and then we have the properties. Type, I think we just need to give a space after the logical ID. So let's just, okay. Now for the image ID, let me get rid of this P. So it's the string type, so we put a default value. So if the user doesn't give any input during the runtime, then we keep it as default. So let me just copy this AMI ID and this be as default, and say allowed values is this, and we can just look at one more value. So we go here and say let's put up Ubuntu. Let's see what's the AMI ID for this one. So this is the AMI ID, and I just put the AMI ID here. So now the user will get two options, and I will get rid of this and say enter the AMI ID from the drop down. Okay, do one last thing, which is just copy this and we'll create the VPC ID. Okay, and I just paste it once more where we'll put the subnet ID. Okay, so this is pretty much it. So we'll say VPC ID Rahul, and it will be string. So default would be n.0.0.0/16. Allowed values can be this, and we can have allowed value as this. So we'll just put in some random values, some values we're putting, so we can VPC cider. Okay, similarly we can have VPC subnet and then string, and we can put the value as, we'll ask the user to put in the values. So I'll just get rid of this. Okay, awesome. I think we have pretty much everything from the subnet perspective. Now just remember one thing, when we created the resources, we hard coded these values here. But if you hard code the values, then the resources that say this VPC subnet that gets created are S3 bucket, then it will take the hard coded values. So what we do is usually we'll just use the values that are referenced in the parameters. So how does this CIDR block get the values which the user has inputted in this VPC ID Rahul? So what it does is, what you have to do is you have to copy this logical ID and then substitute, say this is the VPC, so you substitute with the ref keyword, so use reference and then you put the logical ID. Now what will happen is, when the user puts the VPC value, so here it's the default, when he puts, if he puts the, he selects the drop from the drop down, either this CIDR block or the 24 CIDR block, this is the value that this resource, while it's getting created, will take. Similarly for the subnet, so we'll just copy the logical ID of this subnet and okay. Now similarly for the S3 bucket, let's copy the logical ID for S3 buckets. We'll just copy from here. Okay, S3. So instead of hard coding, we'll use the ref and subnet, and like finally we'll do it for the EC2. So let's copy the parameter logical ID and we'll go to this. Okay, awesome. I think we have pretty much everything except the metadata. Formation metadata. Okay, so we'll go to the interface. Okay, so we already know how it looks like. So just copy this from here and under the metadata, just go paste this. So metadata is already there. Let's just move shift tab and okay, so we can get rid of one of them. Okay, so from the previous lectures we know that you have the metadata and then you can see here metadata and then you have the space. So that's what I was checking. So you have to give some space and add a tab and get rid of this label. Okay, so we'll quickly look at what is a label. So we'll just keep as a network configuration. Now for network configuration, what are the parameters? So this is the syntax. You put a dash, then you put a label and you put the default value what you want. So on network configuration, so what are the parameters that are part of this network configuration? So it will be the whatever we created for VPC. So this is the parameter for VPC. So we'll just copy it and paste it here. Okay, then the next one we created for subnet. So we'll just copy this and paste it here. So we're not creating any security groups, etc. So we'll get rid of this. And then let me just copy this once more because we need it for compute and the storage section. So I just paste it here. So I do shift tab. Okay. This label to compute, and then under compute parameters we had this EC2 image ID. So this is under the, which are the parameters that we have. Okay, I need to get rid of this I, get rid of this key name, and the final one we have as storage. And then parameters. What are the parameters? For the parameter storage, we had the S3 bucket name P. Okay, awesome. So we are pretty much there. Get rid of this. Get rid of the free. Get rid of the lines, black lines. Okay, I think this should be pretty much tags. We have not put the tags properly here. So let's do that. Okay, now do a save. Hopefully there are no template errors. Let me go back to cancel, create stack, Upload file. Let's upload this file. This is the one. Okay, let's as EC2 S3 and VPC. Okay, so okay, it's showing me only two values, so there's something wrong. It looks like I have not uploaded the right file. Let me try and do that again. So choose file. I think I choose this one, so this should be the right file. Let me click on this and let's see what happens. Okay, next. Okay, it's giving me some error. YAML not found, line 20. Let's take a look. Line 20. It's at column 7, and this is at column 5. So it's the structure is not right. So let me just fix this. Okay, so I need to move these as well one step. Save and let's see if it runs. Cancel. It's back. Choose file. Choose this one. Okay, so there is some issue with line 32 column 12. So line 32 column 12. Okay, let's take a look at the parameters. Type and default should be at the same level. So let's see here, type and default. Okay, so we just need to move one step ahead. So that was the error. Most likely, let's take a look. It works now. Let's re-upload. Remember to save the file and then only it will look at the changes. Okay, now it's giving me another error at line 60 column 3. So the previous one we will solve line 60 and column 3. Okay, so this is at column 3 and this is at column 3. Okay, I think this one is not at the same level. Just let me move. So as you can see, it's all about indentation. Let's see if it works now. You'll have some minor errors always. Let's choose file. Okay, seems like it's going to work this time. Now you can see we have the stack name here which we have given, then you have the parameters, and they are now in 3 distinct blocks. So you have the network configuration, which is part of the metadata, compute and storage, and all the parameters that we have identified as part of the network configurations, such as VPC ID. And you can see here you can select either of two. You have the drop down and we see subnet, so you can put your values 0.0.24. So now it's not hard coded. Under the image compute, you have the image ID, so you can select either one, and then you have the storage, so you can name the bucket. So now you can see how that's how you create the metadata, then the parameters, and then the resources. And if you see earlier we had hard coded, now it's taking the ref and the value from the parameters. Okay, and create a stack. You can see all the events that's creating the resources. Here it will show you all the resources. Here it will show you all the parameters that you've added. So you have added the image name, bucket name, the CIDR block for VPC ID and subnet. So you have VPC has been created. You can take a look. Here you will see that VPC has been created. You should also have the tags that we added to it. Project name banking. So if you click on this, click on tags, so you'll see have the project banking and the other tags the CloudFormation creates by itself. You still have the resources getting created complete, so everything is being complete. So you have the subnet that's been created. Now let's open all of them, and you have the EC2 instance. So you have your VPC with subnet, project banking, then you have the S3 bucket, so S3 Rahul 29, and then you have the subnet. If you click on this, you will again see it will have some tags that we used. Okay, you have the Rahul subnet, and then finally you have the EC2 instance, which is getting created. Okay, awesome. It's a very, very long lecture, I know, but hopefully you understood how to use all these together. Okay, let's quickly go through the architecture that we're going to build as part of this use case. So the first thing we're going to do is we're going to create an auto scaling group. So we'll have an auto scaling group with two EC2 instances, and every time we hit the IP of these EC2 instances, we'll get a message saying welcome to this course with Rahul Russell, and it will provide the IP of that particular EC2 instance. Once we create this auto scaling group, then we are going to front end with an application load balancer. So this load balancer will listen to port 80 and HTTP traffic. And once that traffic, port and protocol matches, it is going to send that request to the backend and get a response. The third thing we're going to do is create a CloudWatch log group. This is important because if you want to create a hosted zone, you need a CloudWatch log group. So we'll create a CloudWatch log group with this nomenclature. Once the CloudWatch log group has been created, we are going to create a hosted zone in the Route 53 and then create an entry, CNAME entry, which would map the blog.rahulrussell.com with the host name of this application load balancer. So every time somebody hits blog.rahulrussell.com, it is going to get a message that we had placed in this EC2 instance. What we are also going to do is once we have created this hosted zone and CNAME record, we are going to create a CloudWatch alarm which would monitor the CPU utilization matrix for this EC2 instance, and if it breaches, then it is going to generate a CloudWatch alarm. Once CloudWatch alarm has been generated, it is going to send a notification to this SNS topic that we create, which will have a subscriber like me, and I will have my email ID, which would be subscribed to this SNS. So in a real world scenario, it could be like a group email ID of the admins for that particular application. So these are some of the services that we're going to create as part of this use case. Now let's look at from the end user perspective, how this is going to work. So the end user could type blog.rahulrussell.com in his browser. Then this request would go to his internet service provider like AT&T, which would have a recursive resolver. So this request would then be sent to the root domain. The root domain would see that, okay, now it has .com at the end, and it will send that request to the name server for .com. From there, it will be redirected to rahulrussell.com. The top level domain would see that the domain name is rahulrussell.com, which is hosted in the Route 53. So it would send that request to the name servers for hosted zone rahulrussell.com, which is hosted in the Route 53. From there, it will see that it needs to go to blog.rahulrussell.com and it will look at a corresponding CNAME entry. Once it gets the entry, it will send back the IP to this browser, and all this happens behind the scene. It is done by internet service provider, so you don't need to do anything about it. All you do is type blog.rahulrussell.com in the browser and you will get this IP. Once the browser gets this IP, it is going to make that request to the IP, which would be corresponding to either this EC2 instance or the EC2 instance in another availability zone. And once that request is hit, it will give the message that we would have as part of something that we have on the web server EC2 instance, which is acting as a web server. So now let's quickly take a look on the services that are going to be created as part of this stack. So we'll have auto scaling group, and as part of auto scaling group in this video, we're going to create the launch configuration, auto scaling group, and user data. So what this user data will do is it will provide that message that will be displayed by EC2 instance, which will work as a web server. In the next video, we're going to look at creating the application load balancer. So we'll have to create the application load balancer. We'll have to create a listener, should listen to HTTP and port 80, and then you will have the target group, which would be the auto scaling in this case, which would be the EC2 instances. Then in the third video, we're going to create a CloudWatch log group because that's necessary for creating the Route 53. And we're also in that video, we're also going to create an SNS topic and subscription, which would be my email ID. Then the next video, we're going to create a Route 53. In the Route 53, we're going to create the hosted zone. We're going to create a record set. which is the CNAME, and then we'll use this CloudWatch log group to send all the logs to Route 53. Then in the next video, we're going to create the CloudWatch alarm. So we'll look at EC2 CPU utilization matrix. Every time the matrix hit a certain threshold, then it will generate an alarm and write a message to SNS topic. Once all this is done, the last thing we need to do is we'll have to change the name server for rahultrisal.com. So I own this domain and it is registered, where the registrar that we have is again Route 53. But we'll have to pick these name server details from the hosted zone and then change it with our domain registrar, which is Route 53 again in this case. Only when we make those changes, then once we hit the blog.rahultrisal.com, we'll be able to get the web server message that we have in the EC2 instance. Okay, now let's take a look at all these and build this together. Thank you. Okay, as we discussed in the last lecture, this is the architecture we're going to build. So we're going to start with creating an auto scaling group with two EC2 instances, which will act as web servers. So every time we hit these web servers, you will get some kind of a message. So we'll just put maybe welcome to this course on Udemy, and then the IP address of that particular EC2 instance. So as part of the auto scaling, we are going to create first the launch configuration. Then we're going to create an auto scaling group. And then we're going to add user data to the launch configuration, which will basically run some scripts on the EC2 instance as it is launching the EC2 instance, so that it can then work as a web server and give us some message like welcome to Udemy course. Okay, so now let's get going. Okay, let's create a file. So new text file and do as file save as. So we'll just call it and asg.yaml. Okay, now I've saved that file. Okay, now I just did a search on template anatomy. So I copy the template anatomy, go back and do a paste. So I'll get rid of this output section and we'll get rid of some other sections as well. Okay, so let's put the version date. We go down version and let me just copy this. Okay, description, I'm going to put a quick description. This template creates the auto scaling group. Okay, now we're going to create other resources. So the first thing we have to create is the launch configuration. So you can just do a search, and I already did a search. So here's the auto scaling launch configuration. So this is the syntax. I'll just copy this and let me call it as, I have to give the logical ID. So let me call it as web server launch configuration, and let me just paste this whole thing here. I will move this to a little right. Okay, now let's look at the properties. So I already know most of the properties, but we can, if you're not aware, then you can just take a look. So assert public ID, I'll just show you for say assert public IP address. So it's a no, and it specifies whether the assign public IP address to the group instance. Otherwise, it will assign the public IP by default. So we don't need that. We don't need an EBS volume for now. So get rid of this. We don't need classic VPC ID, VPC security groups. So just get rid of this. EBS optimized. We are okay without an EBS optimized. EBS instance profile. We don't need. You can read through on the documentation. I've already read through. So just in the interest of time, I'll remove the ones which are not required. Okay. So we don't need the spot instances. We can do on-demand security. We can remove placement tenancy. It doesn't matter. Metadata options. We're going to get rid of all this. Okay. And key name, we're going to put some user data. So we don't need to log in to the instance. I'll get rid of this as well. Instance monitoring we don't need for now. Okay. So now we have the image ID and instance ID. We just need either of the two. If you go through the documentation, that's what it will say. So you have the image ID and instance ID. Instance ID is to create the launch configuration when you use, so it gives you some details. So it's not required. Okay. So I'll get rid of this instance ID. Okay. Now we have to put in these details. What we can do is we can create a parameter and then add those details here. So let me call this as image ID, and then we'll do a ref at substitute here. Okay. So I am on the template anatomy, and I will just go to the parameter section. So it just gives me the syntax. So I'll just copy the syntax from here and I will just paste it to this. Okay, I think it's coming with the parameters. So I'll just remove this. Okay, let's just do a copy paste of this because we'll need the instance IDs as well, instance type as well. So this will come in handy there. So I will just move to this and call it instance type. Okay, I think so for the image ID, I will just need some values. Okay, so we can go to the AWS console. Okay, I'm on the AWS console, so let's do a launch instance, and here I can find the AMI. So I will just copy this AMI and we go here and let me put the default value as this AMI ID. So we'll just get rid of all this, everything else. I don't need it. We can put more AMI IDs as well, but just for the simplicity, we'll just put this as the default. And then you have the instance type, is T2 micro, so we can let it be as it is. Okay, now let's substitute the values. Ref and Control C. Again, for instance type, we can do a ref and then we'll copy this instance type from here. Okay, launch configuration name, you can give it, it's not mandatory, but we'll just give it, let's call it web server configuration, and we can also parameterize it, that's fine. We just give it one time. Now the last thing we have to do update is user data. Okay, so you can see here now this user data. Basically what user data does is it's an indexing function which uses function base64 and it returns the base64 representation of the input string. So this function typically passes encoded data to Amazon EC2 instance by the way of user data property. So basically any scripts that you would want to run on the EC2 instance when it is spinning up, you can use it in the user data. So in our case, what we are going to do is we're going to write a small script which will start the HTTPD server, web server, and then we're going to pass some message which will be displayed when the server runs or when you hit the public IP of that server. So I've written a small script here. Basically what it does is it just updates the server first, then it starts the HTTP service, and then it will echo hello from Udemy CloudFormation course with Rahul, and then just I've done a curl and it will give you the public IP of that particular instance. So we'll know if there are two EC2 instances running in different availability zones. We'll know we are getting a response from which EC2 instance. Okay, so let me just copy this and I go here. Okay, so like this. Okay, this should be triple, right? Okay, so I think it looks good now. Okay, we have pretty much everything we need. So now we can go ahead and create the auto scaling group. So let's look at the auto scaling group. So I'm on the auto scaling group page. So let me just copy this. So there's a lot of data there. Let me just go down and go to and paste it here. So I need to put the logical ID. So it's say server auto scale. Okay. Let me make this uppercase. Scale. So let's just see what we can get rid of from here. So auto scaling group name, yeah, availability zone. Let's see what are the mandatory things. Okay, so it's no auto scaling group you don't need, availability zone you don't need. So most of the things are no. You can see here desired capacity. It will give some default value, but let's just put some values. Okay, so we'll put the auto scaling group name, availability zone we'll put, capacity rebalance, cooldown, instance warm up. We'll just get rid of this. So desired capacity is also actually default, but we'll put that value. Desired health checks we don't need. Instance ID we don't need because it's come from the launch configuration. Launch configuration name yeah we need so that it knows where it needs to pick up the instance from. Launch template we don't need. Okay, so lifecycle hooks we don't need. Yeah, load balancer we'll need, but that will be in the next lecture. So we'll just keep it as it is for now. Max instance lifetime size we don't need it. Max size, yeah. Max size we can put like how many max instances we need to have. Matrix collection we're not collecting any matrix. Minimum size, which means number of minimum EC2 instances we need. Yeah, we will put that. And we don't need, I think, all these things. Target group ARNs. We don't need for now. Termination policy we don't need. Okay, and we'll just load balancer. We'll just put it later when we create the load balancer. We'll just remove it for now because we don't have the load balancer. So I'm just going to move this to the right. One more right, and okay, this is now one more right. Okay, I think this is good now. So let's input the name. So auto scaling group, we can also make it parameterized, but it doesn't make a lot of sense because it's just going to be one time. So we'll say okay. Select Rahul ASG. Yeah, just call it Rahul ASG. Availability zones. Which instances we're going to run the availability zones? So let's take a look at our VPC. So this is our VPC. So we'll just pick one. Let's pick this B41 and we'll select it from here. Okay, and then we'll just look at what are the subnets. So we'll pick the subnet one in which is in 1A and the one in 1B. So 1A1. So this is the 1A1. So this availability zone is in 1A. So I just do a copy. We just want to, just for the sake of ease, we just want to put it in 1A, 1B. We can put in any, but so that we just remember. So I'll just put, so it's a list, and then we'll put 1B. Okay, so so where is the 1B? Okay, here is the 1B, the first one. So I'm just going to copy. So the issue is if you don't, because you need to put the subnets as well, later the availability zones as well. So if you put the wrong subnet and availability zone mapping, then it will not work. Okay, okay, sorry, I was supposed to put the availability zone here. I put the subnet, but I will just copy this, and this will require in the VPC zone identifier. So if you see here the documentation, let me go. So this is the VPC zone identifier. Here you need to put the availability zones. So this is condition. So this is basically required. Okay, so just copy these from here and just paste it here. Okay, now we have the subnet. So let's put min size as, we should have at least one instance running. Max size, let's put it 2. Launch configuration name, so we'll do a ref. Okay, ref, and then we'll copy this name from here, logical ID. Okay, this is done. Okay, now we have to give the availability zone. So this was in 2A, US East 2A, and this is coming from here, if you're just wondering. Okay, so the two availability zones we had here, 1B and 1A. Okay, so US East 1A and US East 2B. Okay, so I think we have pretty much everything we need. So let's try and run this. Okay, now let's try it out. So I'm the CloudFormation. So create stack, upload template. Okay, I select this one. It's giving me some error. Line 2, column 41. Line 2, column 41. Oh, I put it twice. Okay, let me get rid of this and do a save. Let's try again. Okay, so there's one more error. 41 column 9. 41 column 9. Okay. So this looks okay. Oh, I forgot this. So let's try again. Okay, let's try again. So do create stack. Choose file. Next. Okay, so let's call it demo ASG. And yes, here are some parameters. So we'll just keep the AMI ID as it is. We'll keep P2 micro. We could have also used the metadata section, but just in the interest of time, I just keep going. So next, create stack. Okay, encountered a non-numeric value for property desired. So let's just see. Oh, we forgot to put the value here. So just put 2 and do a save. Okay, now let's try and rerun this template again. There's one more error that I noticed here. US East is actually, the availability zone is 1A and 1B and not 2. 2 is I think Ohio. Save. So let's try and run this again. So go to CloudFormation, create stack. Hopefully it runs this time. Choose file. Okay, choose a file. Next, let me call it demo ASG01. Image ID will let it be, and instance types also just let it be. We create stack. Okay, let's see what's going on. Create resource in progress. Okay, launch configuration is created. So we're just waiting for auto scaling. Okay, I think it's created the auto scaling group. Let's go. Let's see. Let's look at the instances. Okay. So I think these are the ones still creating. Still showing is pending. Okay, now it's running, initializing. Okay, it should have 2 EC2 instances. So now it's starting both. Okay, let me just copy the IP address of this one. Okay, this is the IP address. If I copy this and I try and access this instance as a web server, then I should be able to get the message that we had put in the metadata. So something like this. Hello from CloudFormation. Okay, let's go and check. HTTP listening on port 80. Okay, great, awesome. So it seems like it's working. Hello from Udemy CloudFormation course with Rahul, and this is the IP address that is part of this EC2 instance. Similarly, the other EC2 instance should work as well. Great. Another thing we can do is we can just delete one instance and see that if it spins 1, because we have desired capacity as 2. So instance action, if I terminate, we should see that there's another EC2 instance that spins up. Okay, so we have 1 here, and soon we should have another one. Okay, now you can see that this one has been terminated and it's spinning up another one, which is in the pending state right now because we had the desired capacity as 2. Okay, awesome. Then this is good. Then in the next lecture, we're going to create ALB and then map it to the auto scaling group. Thank you. Okay, in the last lecture, we created the auto scaling group and the launch configuration. In this lecture, we are going to create the application load balancer. So what will happen is that we are going to access these web servers through the URL or the host name of the application load balancer. So what you'll see is every time, and there's going to be how the traffic is going to be routed is going to be in a simple round robin fashion. So once you hit the ALB, it will message from this EC2 instance, and then next time it will give the message from this instance. To create an ALB, you basically have to create 3 things. One is the application load balancer itself. Then second, you will create the listener as to which port and protocol that application load balancer is going to listen to. So you'll have to create a listener, and then we'll have to create a target group. So target group would be the EC2 instances from the auto scaling group. So we'll have to link the auto scaling group with the application load balancer. So these 3 things we'll create in this lecture. Okay, I searched the documentation page for Elastic Load Balancer and this is what I get. So you have like 5 things you can create. So we're just going to focus on the listener, the load balancer and the target group. It's not going to be HTTPS, so we don't need the listener certificate, and we're not going to create any rules. So rules you can create when you have multiple backends and you want certain path based or host based routing, then you can use that. Okay. So now the first thing is we're going to create the load balancer. So let me click on the load balancer. So here is the syntax. So just copy this and go here. Let me just save as do and load balancer. Okay. So let's go here and under the resources and let's name it as app load balancer. And I'll just put it here. Just let's move this whole stuff to the right. Okay. Now let's see what all is there. IP address type. So let's see what's that IP address type. Whether you want IP address 4 or dual stack, it doesn't really matter. So let's go here and maybe for load balancer attributes, I don't think we need that. It's not mandatory, so I'll just leave it as it is. Okay, so name, application load balancer name, so we'll just call it app load balancer. Let me call it as a raw, so just helps us identify easily. We don't need this is actually not mandatory. Scheme, so I'll get rid of the scheme here. We don't need security group for now. Okay, subnet mapping. So which load balancers these subnets would route the traffic to. So this is one which we had already identified in the auto scaling group because our EC2 instances are going to be in these 2 subnets. So we'll just put it in the same subnets, right? So this is where it will route traffic to. Subnets mapping. Okay, there's a difference between subnets and subnet mapping, I think. So it says you can either use subnets or subnet mappings, but not both. So we'll just use maybe subnets and get rid of this subnets mapping. Tags we don't need. And let's see what is this type. Okay, so what's the application? Where's the application load balancer? Okay, I think that's pretty much it for the application load balancer. Okay, the next thing we have to do is let's go to the documentation, and next thing we have to do is we have to create the listener. So which ports and protocol this load balancer is going to listen to. So I'll just do a copy. So I'm here on the listener, and let me just go down and say application load balancer listener, and I go to the right and just paste it here. Tab, okay, great. Okay, let's see what all is here. Let me do a save. So we don't need what is this ALPN? Let's just check TLS listener. So we don't need, we are not doing secure. So we'll get rid of this certificate we don't need because we are only doing HTTP, not as default action. Load balancer ARN. Okay, port it will list port 80. Protocol HTTPS. Let's see what's there. Port, yeah, you can define the port protocol. So we'll HTTP. Let's see HTTP. Okay. SSL policy we don't need. It's not HTTPS. Now we have a couple of things. So load balancer ARN and default action. Okay. Okay, now we need the load balancer ARN, so we can just do a ref and our application load balancer logical ID. So I can copy it from here and now we have the default action. So let's take a look what that means. So you can see default action is yes and load balancer ARN is also less. Okay, the action of the default rule. So we'll only have a default rule that when the listener is ALB listener is listening to port 80, there's a request. What is going to be the action? Is it going to forward? Is it going to redirect? Okay, so let's see what are the list of actions. If we go here, this is the syntax it gives me. Okay, so let me just copy this and under actions, I need these details. Let me just push it to the right. Okay, let's see what is mandatory in this. These are not mandatory, so no, only the type of action. So whether it's forward, authentic, cognito. So we're not using only all these. We're not doing redirect. We're just forwarding it to the target group. Okay. So if you look at the target group ARN, specify only when the type is forward and you want to route to the single target group. Okay, here we are doing the forward and then routing it to a single target group. Okay, so let's add the details for these two. Okay, let me get rid of everything else. Okay, as we saw, the type is forward. So type is forward. And target group ARN. Okay, so I will just get rid of this. Okay, and then you have the type. Okay, so we have not created the target group ARN, so we'll just leave it as string and then we will add when we create the target group ARN. Okay. Yeah, I know it might seem a little confusing, but this default action, even when you do it through the console, you'll realize that you will have to configure it. Okay, so that's all we are doing. We're just forwarding it to the target group ARN, which is basically what is being created by auto scaling group. Okay. So now let's go and look at this. Let me go back, and then third is target group where the request will be routed, and this should now also map to our auto scaling group. So let me just copy it from here and application load balancer target group. Okay, Control V. Let me just move this over to the right. Okay, we don't need health checks. I'm going to get IP address matcher. I'm going to get rid of all this. Okay, name. I don't think I need name. I'm pretty sure it's mandatory, right? If you see name and all, these are all no, not required. IP address type not required. It will give some default value IPv4 possibly. Name of the target is not required. Yeah, port you have to give. Okay, so let's just get rid of this tag and target to group type. Okay, unhealthy health condition. Okay, we're not going to do any health checks. Okay, so protocol again, it's going to listen to 80. Our web servers are listening to 80. Version, protocol version is not required. Okay, target group attributes. The attributes, the target group, targets. Okay, target type. Target type is going to be instance, as you can see here, because we are routing the traffic to the instance. And what else is there? VPC ID. So let me just check. If it's not there, I will have to copy it. So let's go to VPC, and this was our VPC. So okay, I will copy this VPC from here. Okay, now this is done. So we have the targets and target attributes. Okay, now let's look at this target group attribute and targets. So go here, target type I think we have put, and targets it's not really required, and target attributes, so these are not required. Let's take a look what's there. Okay, so it's just specifying a target group attribute, so I don't think we require it. So let me get rid of these two. Okay, now what we have to do is we have to map this to the auto scaling group, right? Earlier when we had, in the last lecture, when we had created the ALB parameter, we had left it as it is, or rather the ALB property in the web server auto scale. So let's take a look. Okay, now I'm on the auto scaling documentation. You can see here, and let's take a look at the syntax. So here you can see we had the load balancer name somewhere. This is how you will tie the auto scaling group to the load balancer, okay, which would be as a target group. So you have here, so a list of classic load balancer associated with auto scaling for application load balancer and network load balancer gateway. You have to specify the target group ARN property instead. So you have, so for, because we are using application load balancer, we have to look at the target group ARN. So okay, let me copy this property from here and then go to auto scale. So I'll just paste it here, and I'll just do the ref, and you have the auto target group. Okay, application load balancer target group. Okay, the other thing we had was here this target group ARN. So it will be very similar. So it will be again ref, and let me see what I have here. Okay, great. So this is also done. A few things more I need to fix here. So let me get rid of this attribute. It's not required. Protocol would be HTTP, and port number we have to give 80. Okay, let's do a save. Okay, now let's try and run this tag. So choose file, I choose the one. Next, demo ALB01, and we just keep the parameters as default. Next, next. Okay, create stack. Let's see how it goes. It's created a launch configuration. It's failing, so it's saying that value of the property target group ARN must be list of strings in the web server auto scale. So let's go to web server auto scale. So here, so basically it's saying that the target group ARN should be a list. Let me make it a list, and then we can just check and do a save. And let's go to auto scale. Let's see, I just went to the auto scale, the one it's complaining about. So we have to go to the ARN. Let's look at the target group ARN, and yeah, so it's a list of strings. So that's the error So hopefully now it should fix. So it was save. Let me try and rerun this. Okay, let me rerun this tag. So I just upload, choose file. Next, let's call it demo ALB02. Hopefully it works this time. Next, create stack. Okay, so it started. So it's created the application load balancer target group and launch configuration. Okay, so some resources have been created. So we have the web server, launch configuration, and load balancer still be getting created. So let me go to this one till then. Let's see, our EC2 instance should already be should have spun up. Okay, so I have the two EC2 instances. Let me see, I can access these EC2 instances. So let's do HTTP. Okay, so EC2 is now running. Great. Now let's take a look at the load balancer. So I have the load balancer here. Okay, I think it is got created. It's still in the provisioning state. Let me anyway take the DNS name, the host name of this load balancer. You can see all the traffic we are going to route through ALB, and then that traffic is going to be routed to either of the two EC2 instances. So when I hit the ALB host name, then I should get the message from these two EC2 instances. So let me go back. Still in progress. Okay, create complete. Awesome. So everything is got created. So we have the auto scale, launch configuration, target group, listener, and app load balancer. So let's take a look. Okay, it's still in provisioning, but let's try. I'll copy the host name. So let's do HTTP and oh, I didn't put it. Oh, awesome. So I'm getting this message. So these were our EC2 instances 380. So let's go to our EC2 instances, instance types that were created as part of the auto scaling group. Okay, yeah, so we have the two EC2 instances and the IP is 380 and the second one is 54 or not. Yeah, it's still initializing, but the second one is 54. Let's see if we can get these. So we got the first one. Now let's try again. Let's do a little bit of fits and see if we get the other IP as well. Oh, awesome. So you can see now it's got the other IP as well. So 54,211. And if I hit again, it should get me the other one, 380. Okay, so 54 and 30. In the previous lecture, we created the auto scaling group. Then we created the ALB. Now we'll create the CloudWatch log group and SNS. And the reason is that to create the Route 53 hosted zone, you need a CloudWatch log group. So that's why we'll create the CloudWatch log group and SNS first, and then we'll create the Route 53 hosted zone and the resource record. Okay, so the first thing we'll do is we'll create the CloudWatch log group, then we'll create the SNS, and SNS will have two parts, the SNS topic, and then we'll have subscribers to this SNS topic, which would be say my email ID or email ID of an admin. So let's get going with hands-on. Okay, I will save this file that we had previously, and I will write SNS and CloudWatch log group. Okay, so I'm on the syntax or the documentation for CloudFormation. So I go to CloudWatch logs, and here you can see there are multiple things. So I will go to log group. Okay, and it creates a log. So I'll just do a copy from here and then say hosted zone CloudWatch logs, and okay, I'll do a paste and I'll just move this to the right. Okay, I'll get rid of the tags Okay, now let's look at the properties. So you have the tags and retention days. So these are the retention days that you can have. And then you have the log group name. You can give a log group name, so it's not required, but you can still if you want. And then you have the KMS ID. So again, it's not required. Okay, so that's if you encrypt the logs, but we're not going to encrypt the logs. We go back here. So let me just keep it one so that we don't incur any charges. Log group name. We can just give it the same name. Post. Okay. So actually there is a convention on how you can give the log group name. So it's AWS slash 53, the service name, and then your application name. So maybe we'll call it I don't need the KMS ID, so I can get rid of this and just do a save. Okay, that's pretty much it from the log group perspective. Now we're going to create the SNS topic and subscription. So let's call it SNS. And okay, let's go to the documentation now. So let me go here and say SNS. Let's go to SNS topic. Okay, so if you go to SNS, you'll see three things: subscription, topic, and policy. Topic, policy. So we'll just create the topic first, and you can see it just creates a SNS topic. So let me just copy this and we go here. Let's say SNS topic. And this is paste here and move to right. Okay, time was moved a little bit right. Okay, I think this is pretty straightforward. So you can read the documentation, but you can also just make it out from here. So content deduplication we don't need, data protection policy you don't need, and then you have the display should be optional, but let's call it as alerts. Okay, FIFO topic we don't need, KMS ID we don't need. Okay, subscription. So subscription is who are going to be the subscribers. Let's discuss that, but let's remove the tags first. Okay, so that let's remove this and the topic name. So the topic name would be alerts. Okay, now let's take a look at the documentation. So content deduplication is not required. Data protection policy is not required. Display name, it's not required, but we've given the display name. Then FIFO topic, is that need to be FIFO or no? It's not required. Then master key ID, we don't need subscription, list of subscription, so we'll get to that. And the topic name you want to create. Topic name must, okay, some details around topic name, so we created a topic name called alerts. And okay, so now let's look at what is a subscription. So what are the list of subscriptions? So it should be in this form: endpoint and protocol. Okay, before we copy this and proceed further, let's look at the subscription. So let's go to subscription and we'll just copy this and let's leave it here. Let's leave it as it for now. And so SNS subscription, that's my logical ID, and paste here. Right. Okay. Encryption. Okay. So let's look at some of these properties. So delivery policy is JSON. So if you want to take a look at the documentation. So it's not required. Endpoints. Okay. Endpoints, we'll talk about that. Filter policy, you don't need. If it filters some JSON assigned the subscription. Protocol, okay, you need the protocol. You don't need the raw message delivery. Redrive policy, you don't need. We're not going to do redrive. Region, again, we don't need. Subscription role ARN. So this property is only to Amazon Kines data files. We're not using that. Topic ARN we require. So let's go through this. So we'll get rid of the delivery policy. Filter policy we don't need. Protocol we needed. Region and all these things we don't need. Okay. So subscription role ARN, I don't think we need that. That's only for Kinesis. Okay, so we need the topic ARN. So the topic ARN we can get from here, SNS topic. So I will just do a ref and SNS ARN. SNS topic, that's it. That was our logical ID. Protocol. So let's take a look at the protocol. Okay, here's the protocol subscribe. So you could have multiple subscribers. It could be an email, it could be Lambda function. So here are some of the endpoints and protocols. So for email, it is just the email. Okay, so we can replace this protocol with email, and then we have the endpoint. Let's take a look at endpoint. So this is my email, and endpoint is for email protocol. The endpoint is email address. So I'll just put my email address. Call it as gmail.com. I think that's pretty much it. And this subscription we don't actually need because it is not mandatory. We move this to the left. So we have the log group, we have the SNS, and we have the SNS subscription. Okay, now let's run this stack. So I'll create stack, choose file. This is the one we have. Let's see if it works. Next, web app CloudWatch log. Okay, so keep the parameters as it is. Next. Okay, so let's see what other resources are getting created. So we have the SNS topic that's already got created. We have the CloudWatch logs. So let's go to these, and rest of the services are still getting created. The launch configuration is already created. We have the load balancer target group. Let's look at CloudWatch logs. Okay, awesome. So we have the log groups already here. So it will be a Route 53 web app. Now let's take a look at the SNS. So this is the SNS topic that we had created, name alerts and subscriptions. So we had my email ID, which is a subscription, so it is pending confirmation. So I would have got an email saying that please confirm, and then once I confirm, you will see the status changed here as confirmed. Let's just wait for this stack to get completed or create complete. It's still in the process of getting completed. So let's see what are the resources that are already created. Web launch configuration, auto scaling group, SNS topics, subscription, CloudWatch logs, application load balancer. Okay, so yeah, I think only the application load balancer is pending. Okay, I've waited a few minutes, and now you can see that this stack is complete. The application load balancer has been created as well. In the previous 3 lectures, we created the auto-scaling group, then we looked at the ALB, then we created the CloudWatch log group, SNS, and in this lecture, we're going to create the Route 53 hosted zone and resource records. And the objective is that we are going to map the host name of this ALB, which AWS provides, with our domain name, which has been provided in the Route 53. So we're going to create domain name rahuldrasal.com, which is going to map to the ALB. So when we type say blog.rahuldrasal.com or www.rahuldrasal.com, it is going to resolve to this web server IP or either of the two. So as part of the Route 53, we are going to create 3 things: hosted zone, record sets, and CloudWatch log group. So this one we already created in the previous lecture. Now we're going to create the hosted zone and record set. Okay, first I'm going to save this, save as, and we'll call it and hosted zone. Let's just save and so I have already opened the documentation. So you can do a search and open this, and I will go to hosted zone, and let's copy the syntax from here. Just copy here, hosted zone, and here just paste. Just move this to the left, sorry, to the right, and maybe we should move this one step. Okay, I think this looks good now. One step and one step. So this looks good now. Let's just quickly go through the documentation. Hosted zone config, a complex that contains optional element. We don't need that, it's not required. Hosted zone tags, we just skip it. Name, so we have to provide the hosted zone name. Okay, so we can provide that and just see what it says here. The name of the domain, and you have say www.example.com. The trailing dot is optional. Then you have the query log configuration. It sends logs when your domain name is resolved, and if there are any errors, it will just send these errors or just all the logs to a CloudWatch log group. And then if there are any errors, then you can set alarms which will notify a particular email ID. And this is how your log group should look like, and this is what we have done, if you remember from the previous lecture. And that that's pretty much it. And then you have the VPC, private hosted zones. So you need it VPC. If you're creating a private hosted zone, we're creating a public hosted zone, so we don't need it to be resolved within the VPC. So now we have some idea what we need. So we don't need tags and this, so we're just going to get rid of all this stuff. Query log, we don't need the VPC because it's a public hosted zone. We don't want it only to be resolved within VPC. So name, let's call it web server. Oh, name is the name of the hosted zone, so it will be rahul.com. Okay, query login configuration. So let's just quickly. So this is the details of CloudWatch log group. Okay, now the only thing we need to populate is the query logging configuration. So now just let's take a look. So if you go to hosted zone, and then this is the one we are looking at, just click and below you will see query log configuration. So when you go to query log configuration, you can see it is required, and basically you are putting the ARN of the CloudWatch logs. Okay, so you can see here CloudWatch logs ARN. So I'll just paste it here, and okay, so now we have to put the value of this log group ARN, and log group we are already created here, right? Now let's see how we get the ARN for this CloudWatch logs. I just did a little bit of Google how to get the ARN of the CloudWatch logs. So you can also just do a Google and you'll see that this is the format of log group, okay, ARN format. So we can just copy this and then just paste it here, and we can replace the account ID with whatever value my AWS account has, and I can replace the region, and then I can substitute these values. But the problem with this is that if you are going to hard code the values, and now say you run it in the dev account, so you have a different account ID and you maybe have a different region, but when you go to prod, you have a different account ID and you might be running it in a different region. So every time you have to change these hard code values, and that's not what we want. We want that it should automatically pick up these values. So for that, you can use something known as sub function. So it's an intrinsic function. If you do just a search sub function, you can see that it substitutes the variable in an input string with values that you specify. Okay, so this is, let's take a look at example just to understand it better. So here is how it runs. So you have this, and then you have the sub. So if you can see here, you have the ARN. It is going to remain wherever you run. It's going to remain same. AWS is going to remain same. Logs is going to remain same. In place of region, this is the format you put it. So let's just copy it from here, and I'll just put here sub. Okay, so then I'll just substitute the account ID. Just replace it here, and log group name, and log group name was this that we had created. So okay, so now what's the benefit of this? The benefit is that it is going to use AWS region to pick up the values at runtime. So whichever region you run it, it is not, the value is not hard coded. So the value is going to pick up when you actually run the CloudFormation tablet. Similarly, for region, it will pick up the region and it will pick up the account ID. So I think you can copy well. So it should be account ID. Awesome. Save. Let me just save it. Okay, now we have to create the resource record, right? Now let me get back to the documentation. Okay, so what we are going to do is we are going to map that ALB hostname to hosted zone that we have created, which is Rahul Drisal. Now we are going to map that ALB domain name to say blog.rahuldrisal.com or www.rahuldrisal.com. So when somebody hits www.rahuldrisal.com or blog.rahuldrisal.com, it is going to resolve to ALB hostname, which will resolve to the IP address of one of our EC2 instances. So we can do two, either we can do an alias record or we can do a CNAME. So in this case, I'll just do a CNAME. So I'll just copy here and just create a resource record. Okay, so let's take a look at some of the documentation. Okay, wait, so it's not required, so we'll just skip it. Yes, so what is this? Just take a look. So it's a type. You have to provide type in either of these. So we're going to do a CNAME. Let me just copy this and we'll just put type as CNAME here. I'll get rid of this wait. It's not required. Then TTL is the time to live. Let's just put 900. That's about 5 minutes. Okay, set identifier. Set identifier is not required, and resource, that's if you have a routing policy other than simple. So we just have a simple routing policy. So I'm going to get rid of this. Okay, resource records. So we'll just pause this for a little bit. Then you have the region here. Region, you don't need the region. And then you have the change record sets only. It's required. Okay. And then just take a quick look. Multi-value answer, we don't need multi-value answer. Hosted zone name, it's not required. We'll put it, and you can see their hosted zone name. You must include the trailing dot. So if you're putting www.rahuldrasal.com or rahuldrasal.com, then you have to put the trailing dot as well. Hosted zone ID, so specify either hosted zone name or ID. So we're going to provide the hosted zone name. And then you have geolocation routing. We're not going to provide that. Health check IDs, again, it's not mandatory. Okay, geolocation. Then you have the failover, so we're not going to do any failover. Alias targets, so we're going to do a CNAME instead of the alias targets. Okay, I think we know now what all we don't need. So we don't need this region. I'm going to get rid of this region. Names, yes, we need. We need one of hosted name or ID. So I'm going to choose hosted name. I don't need health checks, geolocation, failure, comment, and everything else. I'm going to get. Okay. Now, what is a hosted zone name? So hosted zone name is rahuldrasal.com, and it said put a trailing dot, and the name of the resource record. So name of the resource record, let's call it as log.rahuldrasal.com. We could also have www.com or something else that you want. Okay, now we need to add the resource records. So let's take a look at documentation. So here is the resource record, one or more values corresponding with the value that you specified for the type property. So for the type property, we put in the CNAME. So we have to put the value of how it is going to map to that CNAME host name. And in our case, it is the application load balancer host name. So we need to provide the host name of the application load balancer. Let's see how we can do that. Let's go to the load balancer. Okay, I am on the application load balancer documentation. So if you just scroll down all the way down, function get attribute, and if you need the DNS name, this is the DNS name here. So what you need to do to get a particular attribute, what you have to do is you have to give it the logical name dot DNS name or whatever is it. So if you're trying to get a canonical hosted zone, so you have to put the logical name of ALB dot this. Okay. So let me go back and let me just copy this attribute name. So I will just go here and so get attribute and just paste this DNS name, and on the top we have to get the logical ID of this application load balancer, and just put it here. So now this should give me the host name of or the DNS name of this particular application load balancer, right? And this was string, so let's make it a string. Okay, so there is one last thing we need, which is the log policy. What it means is that any resource that's trying to push logs to CloudWatch log group, say in this case we have the hosted zone, it will need an IAM policy which would allow it to push the logs to the CloudWatch logs. Okay, you can just search for this AWS logs resource group, and this is the policy. This is what policy looks like. You can just copy it here. So you can copy this and then just fill in the details here. So I already done that. So you can see in this policy, what it does is basically you have the principal, which is the route 53 amazon.aws, and the action, it I can create the log streams within the AWS log group that we have created. So I'm just going to copy this policy and paste it there. Let me just put it down and just paste it. Okay, I think we need to copy the whole thing. Okay, let's just copy the whole thing. Okay, so you have the, let's call it log policy and type property. So let's move this to the right. Let's just move this back, and policy name, let's call it log resource policy. And I think we have pretty much everything we need, so we'll run it and see how it goes. Okay, our template is pretty much ready now. Let's run it and see if it works. So I'll go to CloudFormation, create stack, launch. Okay, take the latest one. Next, let's call it web server full stack. Okay, next. It's going to take some time because a lot of services are getting created. Okay, we have created the web launch configuration, the SNS topic, the log policy. We created the hosted zone log group. Okay, hosted zone is in progress, and we have the application load balance. So target group is complete. Okay, we have a few more services that have got created. Okay, hosted zone and subscription scale out are all created. Okay, you can see that now the stack has been create complete. So everything has been created. Let's take a look at the resources. So we have the web launch configuration. Let's take a quick look. And then we have the auto scale with SNS topic, with the subscription, resource records, log policy, and this is the CloudWatch log group. This is the hosted zone, and this is the application load balancer. Okay, so you can see we have a couple of EC2 instances here that is still spinning up. Okay, this one is already up, and you have the auto scaling group configuration, Rahul ASG. Then you have the SNS topic that's created, and you can see that you have the endpoint as rahulrussell.com, and then you have the CloudWatch logs. Okay, and let's see the route 53. You can see that you have the hosted zone rahulrussell.com, which is public, and then you have the blog.rahulrussell.com as the CNAME. Okay, so that's great. I think we have pretty much everything created. Thank you. In the last lecture, we created the Route 53 hosted zone and resource record. In this video, we're going to create a CloudWatch alarm so that when the EC2 instances reach certain CPU utilization threshold, then they are able to generate the CloudWatch alarm and send a notification to all the subscribers to this SNS topic, which we already created earlier, which will send an email notification to the admin that either EC2 instance need to scale up and add new resources or scale down. Okay, now let's go and do some hands-on. Okay, I am on the documentation page for CloudWatch. So let me go here, CloudWatch, and we go to CloudWatch alarm, and then I will just scroll down and copy this. So we can name it as, first we need to give the logical name. So let's say web watch alarm. So this is our logical ID, and then I just paste this whole thing. Let's move it to a little right. Okay. Now let's see other things we need. The first thing is action enabled. Indicates whether the action should be executed during the change in alarm. So say the alarm state changes, should there be action? The default is true, so we don't then require it. Yeah, we want action. We want a scale out or send out an email when it reaches the threshold. So we'll just get rid of this. Okay, so there should be some alarm action. So we know we need that. So next is the alarm action. So we know that we need that, but we'll get to that later. Alarm description, it's not required. We can just skip it, or we can put some description what the alarm does. Alarm name, yeah, we'll put an alarm name so that we know that alarm is getting created. Okay, so alarm description. This alarm is triggered when EC2 reaches CPU threshold. Okay, next is alarm. So we'll say CloudWatch alarm. Let me put Rahul CloudWatch alarm comparison operator. So let's look at the next one. Okay, we need the comparison, the arithmetic operation to use when comparing the specialized status and the specialized values used in the. So yeah, so it is required. So yes, when we say when the threshold, say we are saying that CPU utilization threshold should be 10% or 80%. So when that threshold reaches, should it be greater than or less than equal to? So we'll just put it greater than equal to, maybe greater than or equal to threshold. So when it reaches this value, then the alarm would be triggered. So greater threshold, data points to alarm. So that's the next one, data points to alarm. So it says the number of data points that must breach to trigger the alarm. This is only used if you are setting m and out of an alarm. So if this happens, say you are evaluating after every 1 minute, and this happens like first minute, second minute, third minute. So out of 3 times, how many times should this happen? So you can say even if it happens once every three minutes at the interval of each 1 minute, then it should trigger. So that is a m value. So we will say 1 out of 1. Even the first time it hits that CPU utilization, it should, in the first minute, it should be able to generate the alarm. So we'll just say data point as 1. But if you have threshold value, if you are evaluating every 5 minutes and then you say 3 out of 3, so it will evaluate for 15 minutes and then it will determine whether the alarm should be triggered or not. Okay, so this is an integer. We don't need to put any apostrophes. Okay, and then dimension. The next is the dimension. So we'll get to dimension. Let's leave it for now. Count percentile. So this is not required. We'll get rid of this. Evaluation period. So we're talking about m out of n, 3 out of 3. So we'll just here say evaluation period 1 out of 1. The first time it rings, it should, yeah, you should be able to generate the alarm. So let me get rid of this. Extended statistics, insufficient data actions. So this all will get rid of. Metric name. So we'll put that metric name data query. I don't think we need. Namespace. Yeah, we need that. Okay, action. Don't need. There is, it's okay, then you don't need any action. Period. So after how many minutes or seconds should it evaluate? I think the minimum is 30 seconds if you look at the documentation. So period. Yeah, so it can be 10 seconds, 30, or multiples of 60. So if it is 300, which is 5 minutes, it's free. If it's less than 5 minutes, then it's paid. So we'll just make it 300. So it will evaluate after every 5 minutes. Okay, next is statistics. When it evaluates, how would the statistics look like? Is it after, if you are looking at after 1 minute, every 1 minute, and over a period of 3 minutes, then are you just looking in that 1 minute period? Are you looking at an average utilization within that 1 minute, or is it what was the maximum in that 1 minute? So we'll just put average, or maybe we'll just put maximum. It doesn't really matter. Okay, threshold. Let's look at threshold. Units we don't need. And then we have this one. Unit. See, you can see it's not required. Treat missing data as, so if it doesn't get any data points, how does it, should it trigger the alarm or not? Yeah, so we'll say if it's missing data points, treat it as it's breaching. Okay, so let me just save this. Now we have few more things that we need to namespace. Okay, so for namespace, usually namespace is very standard even if you do through the console. So it will AWS dash EC2, sorry, or whatever the service name. So that's a common nomenclature for namespace. Okay, now this threshold, if you see the documentation, so threshold, so the value to compare with a specified statistic, we need to provide at what level should this alarm trigger. So threshold is what is my CPU utilization. So I'll put it really low too. Usually you will put it at 75%. So if it hits the CPU utilization 75%, then there should be alarm should be triggered, and then there should be some downstream action setting notification to SNS to an admin or scaling up. But here we have to generate a lot of traffic. So what I'll do is I'll put threshold of 2% so that when we do a couple of hits to the web server, it can send a SNS notification. Then we have the threshold. Okay, now we have the alarm action, right? So alarm action. Okay. So alarm action is like you need to specify the specific action as an Amazon resource name. So what happens if this threshold is breached and alarm is generated? What is the action that needs to be done? Okay, so I just clicked on this put matrix alarm. So it's given a sample here. So you can see on the alarm action, you will need to determine whether, if say you are sending, in our case, we are sending an SNS notification to an SNS topic. So this is how you can actually, you just need to provide the ARN of that SNS topic. So we'll just copy it from here and alarm action works here. So we had done this earlier as well, if you remember, and what we can do is we can make this as a sub function, right? Whether instead of hard coding the values as US West 1 and the account number, we can just make it using the sub function, wherein it will then at the runtime pick up whichever account or region that you are running it from. Okay, let's go ahead and look that up. So yeah, so we can specify this thing. And replace this is the account number, and then I will replace the region. So instead of US West 1, region. Okay, and then we have to use a sub function. Okay, so this seems good, and we have to put the SNS topic name. Let's see what is the SMS topic. Go down, and instead of this is the hard-coded value. So I put my SNS topic. And I think I need to put this. Okay, so the only thing we are left with is now the dimensions. Okay, now let's look at this dimensions, and if I go here, so here is the dimensions. It gives you the array of dimensions that you need to look at. So I think I already have it open. So it should be in the form of name value pair. Okay, and if you see, it's an array. So it's also given an example below just for our convenience. So you can see here it is in this form, name value pair. So what it is basically doing is it is from where it is going to look at that threshold value of CPU utilization. So how do you interconnect the auto scaling group with threshold value that we are going to look into today. So that's here. We can just, so it's in the form of JSON. So just need to remove this. Okay. So this is. Okay, so in our case, it's not an instance ID, it is an auto scaling group. And what is the value? So value will have to do a ref, and which will be the logical ID of the auto scaling group. So this is our logical ID. So okay, so let's see if we have done it correctly. Okay, all the data points have been populated. So this looks pretty good to me. So we can just try and run it now. Okay, so before we run this, I think let's just take a quick look. I think we might have missed one thing, which is the metric name. Here's a metric name. The name of the metric associated with the alarm. This is required for an alarm based on metrics. So our alarm is based on a metric, right? So it says no, but you will need that because it's based on the metric. So we'll just simply give it a name. Let me just copy it, and I'll just copy this metric name. Let me just put it here. Let's call it as CPU utilization. Okay, so let me save. I think this should be good now to run. Okay, I ran the CloudFormation template that we created in the last few lectures, and it's created pretty much all the services that we were looking to create when we started off building this architecture. Now let me go to this hosted zone. Let me just click on this. And you can see our hosted zone, rahulrussell.com, has been created, and it has 4 named servers. And then it also has a CNAME, which corresponds to blog.rahulrussell.com and maps to the application load balancer host name that we have. Now, one last thing we need to do in order for blog.rahulrussell.com to give that message is to replace these name servers in the hosted zone registrar that we have, and in this case it is Route 53. So if I go to Route 53 dashboard, you will see that I already have one domain register, which is with Route 53 itself. If I click on the domain, you'll see rahulrussell.com has been registered to me. Okay, you can see here I have these name servers that are already present corresponding to this rahulrussell.com domain. Now what I need to do is I need to replace these name servers with the new ones that are being created as part of the new hosted zone that I have created. So I'll do click edit. So I'll copy these name servers and then just paste it in a notepad. So this is the hosted zone that we had created. So now I will go back to the registrar where I have my rahulrussell.com hosted domain and replace these name servers there. Okay, so I copy this and paste it here. Then I copy the second name server. Then copy the third name server. And the final one. Update. And now it's going to update these details, and we'll have to wait a few minutes for this domain to work. Okay, while we wait for the name servers to be updated with our domain name, what we can do is in the meantime we can just check if our application load balancer gives this message or not. So we'll go to load balancer. I will copy this DNS and let's see if this works. Okay, yeah, great. So it's working. It's giving hello from Udemy CloudFormation course with the Rahul 323634, which is probably the IP of one of the EC2. So let's see if domain name now works and gives a similar message. So I'll just type rahulrussell.com. It will not work probably because it's not updated. It takes a few minutes. But let's just check. Okay, awesome. I think this works as well. So you can see here blog.rahulrussell.com. It's just giving the same message. And if I check the name servers for this domain, it should map to what we have here. Okay, now I ran the CloudFormation template that we created in the previous few lectures, and let's see. So the first thing that we had set out to create was creating the web server launch configuration, and you can see it's already been created, including the auto scaling group. So this is our auto scaling group. So let's just take a quick look. So here we have the launch configuration and details related launch configuration. So we have the user data that we had input. Then we have the auto scaling group. So you can see the desired capacity is 2. So we should have 2 EC2 instances running. So if I go to EC2 instances, so you can see we have 2 EC2 instances running. Okay, so the next thing that we created was application load balancer. So let's take a look if application load balancer has been created. So here we have the application load balancer that's been created. So if we check the DNS name, let's see if it works. Okay, so it's giving a message. So here you have 237.61.34. So if I hit it a couple of times, you can see the IP changes. This is the IP of the second EC2 instance. Okay, so this seems to be working okay. And then you also have the target group, which will be the auto scaling group. So you have 2 targets, which are the 2 EC2 instances. So you can see here. Okay. Now let's take a look at what else we had. So we had the CloudWatch alarm. So you can click on CloudWatch alarm and see if it's working. So you can see it is already in alarm because it has hit CPU utilization more than 2%. Once we hit the Rahul Russell blog.rahulrussell.com or even the domain name for the application load balancer, the CPU utilization has been breached. Now let's take a group at CloudWatch logs. So that was CloudWatch alarm. So this is our SNS topic. We can go to this SNS topic and see if it's been created. Yeah, you can see the SNS topic has been created and it has 1 subscriber, but I have not confirmed the subscription for now. Then you have the log group, which is necessary for a hosted zone. So let's see if any logs have been created. Yeah, you can see multiple logs have been created. As we hit and try to resolve the blog.rahulrussell.com, a request has been sent to the logs. So you can see how it is. So you can see no error because there is a resolution that is happening. Okay, so this CloudWatch log group works as well. So now we have the hosted zone. So we should have rahulrussell.com as a hosted zone, and then we should have the CNAME blog.rahulrussell.com. So if I go to hosted zone, so you can see I have rahulrussell.com as the hosted zone, and this is the query log. So this is where CloudWatch log group has been created and all the logs are getting in push to this CloudWatch log group. And then we have the load balancer target group. I think we already listened. So we've created pretty much everything that we needed. So now let's for one last time see if blog.rahulrussell.com gives us the desired result. So blog.rahulrussell.com. So you can see it is giving this IP. If I hit it again, it should give me the other IP. Okay, you can see another IP has changed. So that's pretty much it from the use case. Hope it was useful. Thank you. Bye. As we discussed in the last lecture, every time a new business unit is looking to onboard its application to AWS Cloud, most likely you're going to create a new AWS account, and then the cloud engineering team is going to create some baseline resources as part of that account. So you will create some VPCs and its components, then run some security baseline configurations. Once that's been done, then that account would be handed over to business unit team, which would migrate the application they have on-prem to the cloud. So as part of this use case, what we're going to do is we're going to create some services that we usually create as a baseline for any AWS account. So we might not create all the services because each organization has different requirements from security and networking perspective. But here we are going to create some baseline services, and then in the enterprise use case 2 and 3, we're going to look to migrate some of those applications to this baseline networking account that we have created. So what we're going to create as part of this CloudFormation use case is, first we're going to create a VPC, then we're going to create subnets. So you have 3 public subnets and 3 private subnets, which would be each in a different availability zone. Then we are going to create some route tables. So we're going to create a public route table, private route table. Then we're going to create the internet gateway, and then we're going to create the NACL security group, and then additionally we'll create an EIP and NAT Gateway. Then outside the CloudFormation, we're going to run an EC2 just to test it out, because in enterprise use case 2 and 3, we're going to create a lot of services such as EC2, but for now we're just going to test it using the EC2. Run this CloudFormation. I just created this high level chart which will provide us some guidance on what is the naming convention and what all we are going to create. The first thing, as I said, we're going to create the VPC. So this is the name we are going to give it. And then the CIDR block for this will be 10.0.0/16. And the resources, yes, we're going to create a resources as part of this. This is the parameter logical name that we're going to use. And this in terms of the metadata, we're going to use the network configuration. Similarly, we're going to create, as I said, 3 subnets. And this is what the CIDR block would look like for each of them. And then some private subnets. Then we're going to create a route table. We're going to create an internet gateway. We're going to create a NACL. So I have just, in this chart, I've just highlighted the naming convention so that it's easier when we actually start naming rather than doing it haphazardly. Similarly, these are the other components. So what are the name for the logical name for NACL? What will be the metadata name? What will the name of the security elastic IP, NAT Gateway, and then finally tags. So tags, the values are going to come from the parameters. So we'll not hard code the values of these tags. So these are very common tags that we use in most application and enterprise scenario, which is the environment, then project name, project ID, and resource name. These are at least the minimum ones. Okay, one thing I want to highlight: if you don't know how do we get these CIDR blocks, relevant CIDR blocks for public subnet or private subnet, what you need to do is, see, basically you cannot have overlapping CIDR blocks for these subnets. So what you usually do is you can just refer to this link I have given here, and when I creating the CloudFormation, I will also show you. You can use this IP address guide to see that there are no overlapping IPs, because /24 usually would have about 256 IPs, /16 would have about 65,000 IPs or so. So I will just show you how not to overlap these IPs, and you can use this guide for getting the right CIDR block. Okay, now let's do some hands-on on this enterprise use case 1. So we're going to follow the step-by-step guide V1.3 that we had created earlier. So the first thing we do is open the Visual Studio Code editor. So let me do that. Okay, and then go to File, New File, give the file name and save it to any folder. So I'll say New File. I'll say CloudFormation Enterprise Use Case 1, and I'll say YAML. Then I will save it in this folder that I have. I'll do a create file. Okay, now I have the new file. So now let's take a look at the next step. The next step is to open the template anatomy. So I'll just go here, CloudFormation template anatomy. Now I'm on this page, so let me scroll down and copy this and go back to my code editor and do a paste. Okay, now let's look at the next thing. So next thing is we have to change the version, format version. Let me just copy from here. Okay, now next is I need to add the description. This is CloudFormation to develop the baseline network resources such as VPC and other subcomponents. Okay, great, awesome. Now we have the other sections. So in this one, we are going to use the template version, description, metadata, parameters. So we're not going to use the rules mappings for now. So I'll get rid of them. And conditions. Okay, we just have resources. Okay. Great. So these are the 5 sections we are going to use for now. These are critical. The rest of them are optional sections, which we'll take a look at later. I don't want to overcomplicate things, because if you can create with these 5, this baseline template, that'll be like you're almost 90% there. Okay, so we'll start with the resource section, and let's look here. The first thing we have to create is the VPC. So let's do that. Here is my resource. Okay. Okay, hope you remember the syntax for resource. So you have the resource keyword, then you have the logical ID, and then you have the service that you're trying to create. So hopefully you remember this. Next, I will just go and search AWS CloudFormation VPC. Okay, I'm going to search that. We have done this before, so it should be pretty straightforward. So here is my block. So the first thing is I have to give the CIDR block, then enable DNS host names, and you can read the details here. The only thing required is conditional. So I will also enable the DNS host name and DNS support. We want to be able to resolve the resources within the VPC. Okay, so we already have the keyword resources. So I will give it some logical ID. I think we had it here in the PPT somewhere. So we'll call it as VPC01. VPC01. That's my logical ID, and then I keep some space and I paste this type. Okay, let's do a tab, a shift tab if you want to move it back. Okay, one step more. Bring type also at the same level. And this header block is what we had done was 10.0.0. We can actually hard code it, or we can give it like the parameter name and let the user put it. So we'll just use the ref keyword. Okay, and here we had said, okay, this is the parameter that we are going to use for this one. So I will just copy this, copy, and this is the value. This is where it is going to take the value from. Okay, and enable DNS host name. We'll write it as true. Enable DNS support. Yeah, we want to allow that. It's again a boolean, as you can see here. And instance tenancy, I don't need the, if you look at the documentation in instance tenancy, it is default is, you can see here. So yeah, the tenancy by itself, it will take a default, the value if you don't give any value, otherwise it can be dedicated. So we'll keep it as default, so we don't need to provide any value. So I'll get rid of this. I don't need IPAM, I don't need the net mask, so I'll just get rid of all this stuff. Okay, tags we need, so let's take a look at the tags that we had defined. Okay, so here are the tags. So just put it like this, environment key, and then we just go and value. Okay, similarly let's put the other key, the other tags as well. So this is a very typical, this is how it's the kind of tags you would put in enterprise settings, and that's like a minimum. So we just have to do it one time, then we can just use the same tags for other services as well. So value, and this is project ID, and this is resource name. Okay, I just get rid of these three, get rid of this. So parameters, we know the syntax again for parameters. Let's take a look if you don't remember. Okay, here's the one. So you have the parameter keyword, then you have the logical ID, and then you have details below that. Okay, so for parameters, the first thing we have to write is the VPC01. So we'll just name it as like P, probably. I'll just maybe change. We'll just show that you can see here. So we can just call the VPC01 and P as parameter, the logical ID. Okay, so now we'll give some space, and let's just search the syntax for parameters. Okay, so just go here and go to parameters. So this is like typical syntax. I'll just copy this and I'll just paste it here. Okay, so this is the parameters and this is logical ID. Okay, so yeah, this looks okay now. And type is, we know it's a string, so default. So 16. So we will have some CIDR block like we have defined here. So CIDR block. So if you see how a CIDR block is defined, let me just quickly show. Okay, now say you want to define a new VPC. So first thing is that you will determine how many IP addresses you need. So how is that done? With help of this /16, you can see. Say you want 65,000 IP. So you do 32 minus whatever number you put slash here, and it will be like 16, which is equal to 2 raised power 16. So you have 2 raised power 16, which will be around 65,000. Then if you want, say, very small number, so you say you put 28 n.0.r/28. So that will be 32 minus 28, which is equal to 4, equal to 2 raised power 4. So that will be 4 into 4, 16, right? 16. So you will have 16 IPs. But out of the 16, 5 will be reserved by AWS for their internal purpose. So you'll have just 11 IPs, right? Which will be reusable. So that's how we determine the CIDR block. So we'll just take this is just an sample that we're trying to create. So we'll just keep like 65,000 IPs. So we'll take a /16. Okay. This is the default, and then we'll give a couple of allowed values. Okay. 0.016, and we'll say n.0.0.0 slash say 24. So we'll say enter the value of VPC CIDR. Okay, and then we'll use the values for the CIDR block that we had here. So that will be the logical ID of this. So just copy here. And now the next thing we have to do is give parameters for the tags. Okay, let's name it as tags. Let's call it project tags rather. Okay, so we have it in the same line. And we will keep it short. So let me call it as type. Okay, so we'll call it type, and we will not provide any allowed values. So we'll just get rid of this, and okay, so enter the name of the project. So this again project. Let's call it project name, and let's copy this and we'll just put it here. Enter the project ID, enter the name of the project ID, get rid of this default, okay, and we have a couple of more tags. So we'll name it as resource ID and enter the name of our resource source. Okay, so that looks good. The only thing we have to put it is the environment. So for environment, we'll just limit the scope of values that a user can add. Okay. So now move to select. Okay, so this is name password. This will be the environment. Okay, and the type string, and default we'll put it as dev, and allowed values will provide dev and let me dig it up. Okay, dev, and this will be dev and dev dot. Okay, so environment type. Okay, so this looks good. Then we have to substitute the values here. So this will be ref and what is the logical ID of the environment. So it's just the environment, and what is the for the project name? It's the project name. So ref project name, and similarly for this one, ref project ID and resource. So it's a resource ID. So this will be ref. Okay, we should have one more, which is which should be resource name, and let's add here. Okay, resource name, enter the name of the resource, enter the name. So you have the project name, you have the project ID, and okay, so actually I just duplicated this. I should get rid of this, enter the name of the resource. Okay, I think we have pretty much everything. The only thing we have to now add is metadata. So let's take a look at the syntax. Okay, so here is the syntax if we don't remember still. So we have the metadata keyword, and then you have this CloudFormation interface, and then we have the parameter groups, then provide the label, name of what would appear like network configuration storage. Then you put the default name, and then you have the what are the parameters under that. So I already have this open syntax for metadata, so I'll just copy it from here, and I will go here and just paste it. Just move it a little left, shift tab. So there's a duplicate. I will remove this. I will leave everything as it is. So let me get rid of these things. Okay, so we have the label. So we'll leave the label as network configuration because these are all network items, and the parameters. So what are the parameters that will be under the network? So we only have VPC 01P, that is here. Okay, so now that's about it. Okay, I'll get rid of this for now, and now the second label would be tags, right? So we can have it in a structured fashion. Okay, so we'll call it as tags. And what were the tags? So we have environment, we have the project name, then we have project name, project ID, and resource name. Project source name. Okay, let me just do a save. So we have pretty much everything we need. Reduce one space here. These are parameters, and these are the resources. Okay, awesome. So hopefully we have everything. Now let's run this CloudFormation stack. So I go to create stack, choose file. Okay, this is the file name. Next. Okay, it's giving some error. Every parameter must be an object. So let's take a look. Okay, these are my parameters. Let's look at the syntax. Okay, I think this might be the error. You can see that these are the logical IDs, but I have the description here, which is under the logical IDs line. So let me just move to left and back to this. Let's run that file again. Okay, let's call it test01. Okay, I have the parameters and network configuration. I have the options. I'll keep it as default. Then we have the environment tags. So you have the environment, and then project name, let's say credit card, project ID 123, resource name, so we're creating a VPC 01. Okay, next. Okay, leave everything as default. Next. Create stack. It's creating the stack. Okay, awesome. I think it's created, so you can see the resources here. The VPC has been created, so I'll just delete this one for now. Okay, we created the first thing, which is the VPC with the particular startup block. Now let's focus on creating the subnet, wherein we'll have 6 subnets as shown here, and then each subnet will be in different availability zones. So 2A, 2B, 2C, and then private subnet again 2A, 2B, 2C. And then we'll provide the CIDR block for each of them. And then we are going to create the internet kit. Okay, so let's get going. So remember that we're going to create 6 subnets, and these are the CIDR blocks that we had provided earlier. So let's create them. So I'll just do a search here and AWS CloudFormation Subnets. Go down this page. Okay, so this is the syntax. So let me just copy it from here. Let's take a look at some of the values that are there. So assign IPv6, we don't need. Availability zone, definitely we need to provide availability zone for each of the subnet. Then availability zone ID, the ID of the subnet, we don't need that. Then we need to provide the CIDR block for each. They should not be overlapping, so we'll provide the CIDR block. Enable DNS64, we don't need that. IPv6 we don't need. Native. So, and then finally the tags. It's not an outpost, so we'll just skip all those things. So I've just already copied it. So I'll go below the resource section and let's go here, paste it here. Okay, let me just do a tab so that it's under the type. Looks good. Properties I need to move a little bit, and I need to provide the logical ID here. So my first logical ID was, let's say this, let's see, so you can give any name, but let's get this name, public subnet 1, and here it is. Okay, so now I think it looks good. So we'll get rid of this. We need this. So availability zone, yeah, so let's put it like this. Public subnet 1 is always going to be in US East here, US East 2A. Unless you want to run it in multiple regions, then you can parameterize it. Availability zone ID, we don't need. CIDR block, so our CIDR block here was 10.0.0./24. Again, we can parameterize this as well, but just to make it simpler, I'm just going to hard code these values. Otherwise, you can provide it in the parameter section, and then the user can provide this CIDR block. I don't need to enable DNS. I don't need all of these. I'll just get rid of everything else. So see, if you don't provide even the availability zone, it will take by default, but that's not what we want, because we're going to create multiple subnets and you don't want it to provide same default value. So that's why we're hard coding the value here. Then one important thing is VPC ID, right? To which VPC it belongs. So I can do a here ref, and then this is my logical ID of my resource. Just copy it from here and just paste it here. Okay, tags, I'll just use the same tags. Okay, copy paste. Let me move back. Shift tab. Okay, tabs are under this, just one to the left of the properties. Okay, one more. Okay, one more. I think awesome. So environment name, it will take the same. Project name, only the resource name we have to provide. So I will just hard code the resource value. So let's say resource name is public subnet 1. We'll just hard code it. We can also provide as a parameter, but it's fine. We just hard code it for now. Okay, VPC ID. So awesome. So this is done. So we have to just copy now the same thing multiple times, because we are going to create multiple public subnets. Okay, just move to the left. Okay, move this whole a little to the right. Okay, I think it is good now. We'll change this to 2, and we'll just change this to 2b, and we'll just change to 1, and rest everything else remains same, just the key value we change it to. Okay, now let's do another one. So I'm just going to pause a little bit the video, and I'll just do a copy paste, and then I will just change the values. Okay, I've just done the copy paste. Let me change the values now. So this is public subnet 3, so we'll make it to C and change this decider block so that it's not overlapping, and change this to 3. Okay, now we have to make this now 3 public subnets. We have to create 3 more in the private. So I'll call it private subnet 1, and it'll be US2A, and we'll just call it like 3.0, and this will be private subnet 1. Okay, similarly I'll just change the values for the rest of the 2. Okay, awesome. So we have pretty much created all the 6 subnets which are part of our base VPC with the ref. Now let's take a look at what's the next section we need to create. Okay, so we created these 2. Let me use colorful. Next, we have to create the internet gateway. So when we create the internet gateway, there are 2 things we need to create. One is the internet gateway, and then you need to attach that internet gateway to the VPC. Okay, so let's do that. Let's do a Google. So internet gateway. Okay, here is the internet gateway. Okay, it's pretty straightforward. So you can see here, I'll just do a copy for internet gateway, and then go here. First we have to give a logical ID. So let's call it let's copy from here. So internet gateway, so let's call it IG01. Okay, IG01, then do a colon, and then the syntax that we just got. So do control V. Oh, I'm sorry. Okay, I have to copy from here. Okay, so I have to move this to the right. So properties, the only thing is we need the tags, and so everything remains the same because the project ID, environment, everything is same. Only the resource name changes. So it will be internet gateway. Okay, so I'll just do a save. Next, we're going to create the internet gateway VPC attachment. So let me do a search. Okay, so I'll do a search VPC gateway attachment. Okay, so here I have the EC2 VPC gateway attachment. Attach the internet gateway or a private gateway to VPC. So this is the syntax for this, and because you see in the internet gateway there is no way where it is defining how it is connecting to the VPC or to which VPC it's going to connect. So that's what this VPC gateway attachment does. Okay, so here is the one. Okay, right. So let me call it VPC gateway attachment. That's my logical ID. Yeah, I have to move to the left. Okay, okay. Okay, so you know what all do I need here? Okay, so these are some of the parameters. So let's take a look at what is the internet gateway ID, the ID of the internet gateway. We can get that. So either we have to use internet gateway or VPN gateway ID. So either of the two, and the ID of the VPC. So ID of the VPC, we know we can use the logical ID. So this is what we can copy so that it can attach to this particular VPC. So I will do a ref and the logical. Okay, I need either of the two, so I'll get rid of this. And internet gateway ID is the one which we created here. So again, we can do a ref and copy it from here. Ref. So once this internet gateway ID gets created, then it will attach to the VPC based on these two values. Okay, awesome. So now we have done these two as well. Now we need to do the route table. So we'll have route table, the public route table, private route table, and then associate these route tables to the subnet. Thank you. Okay, in the previous lecture, we looked at creation of VPC, subnets, internet gateway, and internet gateway VPC attachment. Now in this lecture, we're going to look at how to create default route table, then create public route where we'll attach the subnet to this public route, and then we'll create a private route. Private route may not be required in this case because only when you need the resource to send traffic to NAT gateway, then you might need private route. Otherwise, we will not need that. So in this lecture, we are not creating the NAT gateway, so we'll skip that for now. And then finally, we are going to do the subnet route table association with the route table. Okay, so one thing I wanted to highlight here is that earlier we put the availability zone as US 2A, which I just realized is not correct. So if you go to CloudFormation and if you look at North Virginia, is US East 1 and not US East 2. So that change we need to make, and I'll just make that change. Okay, so I made the changes to all the wherever we had the availability zone. So next what we need to create is the route table. So let's go to the documentation and let's search for route table. Route table. Okay, here we have the route table. Okay, so as you can see here, specify the route table for specified VPC. After you create a route table, you can add routes and associate the table with the subnet. So that's what we need to do. We'll just copy this from here. So it only has the VPC ID to which we need to associate the route table to. So it's pretty straightforward. So let's go here, provide the logical ID. So we'll say route table, and we're just going to put it here. Let's push it a little this side, and tags we're just going to copy from here and just paste here. Okay, so it looks okay. So we need to give the resource the name route table and VPC ID. So we'll just do a ref, and what is our VPC ID? VPC01. So just copy the logical ID from the top, and okay, ref, control V. Okay, so now we are done with the route table. So next we are going to look at public route, because we need the subnet, public subnet, and it needs to have a route to the internet. So we'll need to look at that. So we'll look at the routes. So here we have the route table, and then here we have the routes. Specify the route in the route table with the VPC. Okay, so we'll just copy it from here and we'll just call it public route. Okay, and just do a paste. Let's move that to the right. Okay, so type, we'll just move a little back. Okay, type. Okay, so let's see what are the relevant fields for us. Carrier gateway ID, we don't need that. Destination CIDR block, the IPv CIDR block for the destination match. Yeah, we need this. So we'll get rid of this. Okay, destination CIDR block. So where will the traffic be routed towards in this subnet? So it will be routed towards the internet. And what is the IP for internet? So you just reference it by 0.0/0. So that means all the traffic will be routed to internet. So destination IPv6 we don't need, we are only doing IPv4. Egress internet gateway we don't need. So we have the gateway ID and instance ID. Let's see what are those. Okay, then we have the gateway, the ID of the internet gateway, or the, okay, so we can, this we need to provide. So we'll do a ref gateway ID. So this is the internet gateway ID. Internet gateway ID. Okay, so what is the internet gateway ID? Internet gateway ID is this. Okay, so just copy this and paste it here. Okay, next is instance ID. So instance ID is a NAT instance. We are not using a NAT instance. Local gateway ID with NAT gateway we're not using. So get rid of all these three. In network interface ID. So we're not creating any network interface ID. A route table ID. So we just created a route table. So we need the route table ID. Again, we're going to do ref route. So you come from here. The logical name is the route table. Okay. So transit gateway, we're not creating any transit gateway, we're not creating any VPC endpoints, and we are not creating a VPC pairing connection. So let me get rid of all these three. Okay, there is something I want to show you before we proceed here. So there is something known as depends on attribute. And if you can see here, it depends on attribute, you can specify the creation of specific resource that follows another. When you add depends on attribute to a resource, that resource created only after the creation of the resource specified in depends on attribute. So what it's trying to say is that there are certain resources which you need to create after the previous one has been completed. So if you put the depends on, then it will wait for the other resource to get created and then create the second resource. Sometimes it can happen is that the second resource gets created first and it's looking at a value for the first resource and it will fail. So that's where you should use the depends on. So here you can see you have the depends on when depends on is required. Some resources in a VPC gateway, if your CloudFormation template defines VPC, a gateway and a gateway attachment, that's a VPC gateway attachment. Any resource that requires gateway are dependent on the gateway attachment. So here you can see you have the Amazon VPC routes that includes the internet gateway. So you have a route to the internet gateway. And when you are doing that, it needs to go after VPC gateway attachment has been completed. So that's where you need to use this depends on attribute. So let me just copy it from here and let's go here. So it will come after the type. So I do control V, depends on, and this will depend on VPC gateway attachment. Just remember that you don't, when you use depends on, you don't use a ref keyword. Okay. So VPC gateway attachment. So I will do a save. Okay. Next is the private route. So private route we don't need. It will associate with the default route and which will route the traffic internally within the VPC. Only, as I said earlier, if you are looking to add NAT gateway, then you should use the private route, which will route the traffic bound for internet to NAT gateway. So that route you will have to create. Now let's create the subnet route table association. Okay. Okay, so we did a search subnet route table association, and here I get it. Okay, so I will just copy this and then okay, so call it public subnet one route table association. Okay, and we'll just move these to the same level as type, and then we'll just give them one more space. Okay, so here we are trying to associate the public subnet with the public route that we have created. So route table ID. So route table ID is this one. So it's a route table. Okay, so the route table is this. So let me just copy here and substitute it. Okay, so ref and v. this will be the ref, and this will be the public subnet, right, to which we are asserting this route table. So this is public subnet 1. Okay. Okay, so we needed to do it for all the 3 subnets which have a route to the internet. So this is the second one and this is the third one. Okay, let's now change this to 2. This is 3 and this is 3 as well. Okay, so this is pretty much done. Okay, now let's quickly run the stack and let's see if it works. So choose file. Next, let's give it VPC CloudFormation template, and site block is fine. Dev, you can say credit card division and project ID 1 2 3 4 5 6. Next, and create stack. Okay, hopefully it will work. So let's see the resources. It's creating the VPC and the internet gateway events. Okay, so refresh it. So it's already created the VPC. So this is our VPC, and let's see if the tags are there. Okay, so we have the environment dev, project ID 1 2 3 4, resource name is VPC. Okay, so here's our VPC, and hopefully it should have 6 subnets. Okay, so internet gateway, let's take a quick look at the internet gateway. Okay, you have the internet gateway that's attached to this particular VPC E01, and what was our VPC? Yeah, E01, so it's good. Okay, so pretty much everything has got created. So you can see here, so we have the VPC that's there, route table, public subnet 3 2 1, route table station, private subnet, public route table, and VPC gateway attachment. Okay, so I think everything looks good and it's working fine. Thank you. Okay, now let's create in this section security group and NACL. So I will just open the current file and save it as font 4. Okay, so now we're going to create a security group. Let's do a quick search. So I did a quick search on the security group, and this is the syntax that I got specified as a security group. Okay, so I will just copy it from here. And okay, so this is the logical ID, and just do a paste. Okay, so I'll just move this to this side. Okay, now let's see what are the properties that we need to look at. Okay, before I just add the data points here, let's take a look at what security group looks like. Okay, so here is the security group from the console. So if I go to one of the security groups, okay, so it has a security group name, security group. So this is the description. Now let's take a look here. So group description, this is required, yes. So let's put some group description. Let's say this is a sample security group name. So the name of the security group, is it required? No, so just get rid of this. Okay, security group egress. So now in the security group egress, that is the outbound rules. Okay, Okay, so here is the security group. So let's take a look at the outbound rules. So I click on outbound rules and I do edit outbound rules. So here you can see, so first thing is the protocol. Okay, so I can say here all TCP or custom TCP, and then I can put the port number that I want this particular resource to listen to. If you see, the security group is a resource specific capability or a service. So whatever, say you have a web server, so if it listens to 80 or 443, then you have to provide that port range, and then you have to provide the IP range that this traffic can come from. So it can be 0.0 slash, that means it's open to internet. So if it's a web server, it will be open to internet. Or if it's say a database server, right, then you want only the traffic to come from a particular IP, say the IP of app server. So you can just specify your IP 172 dot something 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 slash 32. So slash 32 is just one IP. So let's use this knowledge to then transfer it while writing the CloudFormation template here. So there's also a sample. If you go to sample and look at the sample rules, then you can just see it from here. Let me just copy it from here. So I will just replace this here. Okay. So you have the security group ingress and you get the security group egress. The first thing is, what is the IP protocol? Like we're looking here. So what is the protocol that you're looking at? Let's say it's TCP. So because it's egress, that means the traffic is going to be outbound, right? And usually for the outbound, if you see, it's already outbound. Usually you will allow it to the entire internet, right? Because the security groups are stateful. So it would be from say internet to you, and then the outbound, it will anyways, whatever is initiating the connection, then it will get a response, whatever be the port number. So it's usually always all traffic. So then from port, which is for the outbound, the resource, say a web server, would be the outbound port. It can be formal or it can be anything. So you just put it 80 to port, say you are sending it to port 80, then this is the destination port. And as I said, the traffic could go to just anywhere. It doesn't really matter because security group is stateful. So you put it 0.0.0./0, which is anywhere on the internet. Okay, now let's take a look at the security group ingress. Okay, again for the inbound rules, it's a similar thing. I do it inbound. So you have the protocol, then which port your resource listens to. Say like this is 22 in this case. If it's a web server, it can be 80 or 443. And what is the CIDR block that you are allowing traffic from? So in this case, again, we'll list with the protocol will be TCP. From it can be anything. You can also change it to anything else that you want, or you can put it like -1, which means that it can come from any port. And to port, your web server will listen to port 80. So you put port 80, and then it is open to CIDR IP, which is open to the internet. So this is what you will put show as is, can anyone from the internet can access this. Okay. So now I will have to change just the tags. Copy the tags from here, and below the tags we have the VPC ID, right? So which VPC it will be associated with. So I just copied the VPC also ID from there, and tags remain pretty much same, only the resource names changes. So we can say security group. Okay, so let's save. Okay, now we can run this back and see if it works. But before I run this template, let's just make the security group maybe a little more secure. We'll just put port 80 instead of opening it to all. So let's do a save. Let me go to the CloudFormation template. So the CloudFormation service. Okay, create stack, choose file. So I hopefully have saved the file. Just resave it. cancel, create stack, choose file. Okay, next, security group VPC, and okay, project name, credit cards, and project ID, that's 88, some random number. Okay, now next, create stack. Okay, it's going to take a little bit of time to create all the services. Okay, it's created some services. Security group creation is in progress. Okay, here's the security group. Okay, looks like it's been created. Let's go to resources, and okay, the entire stack has been created, so it's complete. Let's look at the security group. Okay, you can see the security group, and it has inbound rule which is 80, and outbound should be 80 as well. Okay, awesome. So this is great. Now we'll create the NACL. Okay, now let's create the NACL. So I will just go to the CloudFormation template. So I just did a search and it showed up AWS EC2 network ACL. So specifies a network ACL for your VPC. So this is the syntax. So basically you just have the tags and VPC ID. Let me just copy this and we'll go to the resource section. Okay, let's put NACL, and that's my logical ID. Okay, so let's just move to the right. Okay, so I think it looks okay. Okay, great. So now tags, we'll just copy the tags from here, and then you have the VPC ID. So this is pretty much all you need. Tags and VPC ID. So tags, everything else remains same. All these values will be taken from the parameters that we had defined, and resource name would be NACL, and it requires the VPC ID, which anyway we'll use a ref to get it from the logical ID of the VPC. Okay, awesome. So we're done with one part. Now we need to define the rules for ingress and egress. The NACL is stateless, so you need to define both inbound and outbound rules. So for that, if you just go to the next one, network ACL entry, this should provide you those details. So to declare the entity in your AWS CloudFormation template, use this following syntax. So we'll use this YAML index, the syntax. Okay, so let's say NACL entry. Right. Okay, let me move to a little left. Okay, great. I think this looks good. So now let's look at what are the things it's asking for. Okay, the first one is the CIDR block. So if I go to the documentation, you can see it specifies the IPv6 CIDR block arranged to allow or deny in CIDR notation. So for now, we'll just make it open. So we'll put it anything from the internet can come and access our server. Okay, egress. So let's take a look at egress. So you can see whether the rule applies to egress traffic from the subnet or ingress false. So whether you want to define it for both ingress and egress. So we'll put it false because this is ingress. We don't want egress. So let's make it false. Do you want ICMP? So I just get rid of this. IPv6 CIDR block, I don't need it, so I'll get rid of this. Network ACL ID, so that will be this what we have created here. So we can use the ref and an NACL. Okay, now what is a port range? Now let's go and take a look. The range of port numbers that you want to allow. So if you want to allow only TCP, then you have to specify 6. If you want to select UDP, you have to use 17 protocol parameter. If you want to, yeah, so that's, I think that's what we need. So we'll use the TCP. So we just put port range as 6. Okay, so port range would be 6 as we're using TCP. Then protocol again, if you see the documentation, here's the protocol. So you either specify the protocol or you can specify -1, which means you are allowing all port ranges open. Okay, so now you see there are two things, port range and protocol. So what it says is that if you specify -1, then this port range property is ignored. Okay, and this is required and this is not required. So what we can do is optionally is just put -1 in the protocol, then we don't need to put the port range. So let me do that, because this is a NACL and we are using web servers, so we can possibly open all port ranges, though ideally we should only do 80 or 443. So I'll get rid of this port range. And rule number we have to put. Rule number is usually you put it in increments of 100 and then increments of 10, because when you are using NACLs, the rules are evaluated based on the rule number. Unlike security group where all the rules are looked at and then a decision is made, in the NACL, the evaluation is done on based on the rule number, and if you have a higher rule number and the property meets, it is going to allow the traffic, right? So rule action. Okay, so you have rule number, rule action, allow or deny, and then you have the rule number. So rule action is allow, and then rule number is 600. Okay, awesome. So this is for entry. Similarly, we have to create one for the exit, because it's NACL is stateless. So we'll say NACL exit, and we'll just put silent block, because this is fine. Only thing we have to change here is we can make it, and we'll make the rule number as maybe, let's make it 200. Let's say. Okay, now let's run this template. So what we are going to do is we're going to use the same template, the resources that had already been created, and just update this template. So what it will do is it will only make changes to this template where there has been any change. The rest of the resources it's not going to create. Okay, so this is the previous one which we ran with the security group, which has all the resources created. So let's do an update, replace the current template, upload new template, choose file. Okay, here is the one I upload. Okay, to the next, hopefully it works. Okay, showing me if I want to make any change to parameters, I don't. Next, and next, update stack. Okay, update is in progress. Okay, NACL creation is in progress. Everything else doesn't change. You can see everything else is complete. Okay, NACL has been completed. Now we have the entry and exit that's been created. Okay, awesome. So everything is now complete. You can see 2 ACLs have been created. So this is the NACL. Okay, so the NACL, this is the NACL that's been created. So we have the entry, exit, and let's take a quick look. Okay, you can see rule number 100 that we had created for all traffic from source internet, and then outbound, I think we had created rule number 200. Again, allow. Okay, great, awesome. So in this lecture, we completed the NACL. Next section, we are going to do Elastic IP and NAT Gateway. Thank you. Before we get into how to deploy the CloudFormation using the AWS CI/CD pipeline, let's do a quick review of what an AWS CI/CD pipeline means. On the top, I have highlighted here all the AWS CI/CD pipeline tools, and below I have highlighted the market equivalent of those tools. How does a CI/CD pipeline work? First of all, our developer would clone the current code base that he has for that particular application on his IDE. So it can be an Eclipse, or if he wants to use AWS tools, then you could use AWS Cloud9. So once he has cloned the current repo, he will make some changes based on his user story and then commit the code. So if he is using AWS, then he can commit the code to some kind of source code repository like AWS code commit. If he is using a third-party tool, then he could probably be committing the code to GitHub. Once the code has been pushed to GitHub, usually there would be an automated trigger which would start the build process or code build process in general. And for that, you can use AWS code build. Similarly, if you are using third-party tool, then you could use a combination of Jenkins, which is a CI tool, along with Maven or Gradle, which will do the build for you. Once the build has been done, then an artifact would be created, which can be pushed to something like a JFrog, and from there you will carry some kind of testing. So you could use multiple tools in combination with AWS code build, such as Selenium, etc., which can help you carry out the functional testing. Once the functional testing has been done, then you could use either AWS code deploy or CloudFormation to deploy those artifacts to dev, QA, or prod environment. Similarly, in the other than AWS, you could have Octopus deploy or some tools from IBM which you can use to deploy to higher environments. Finally, then on the monitoring side, you can use AWS CloudWatch, and if you are using some external tool, then you could do something like Dynatrace. So this is at a high level how you can use various AWS tools. So basically you use if you have to use an ID, use AWS Cloud9. If you want to use a source code repo, then use AWS code commit. For build, you use AWS code build. Test you can do using AWS code build and some third-party tool like Selenium. And for deployment, you can use AWS Cloud Deploy or CloudFormation. And then finally, you can do the monitoring using the CloudWatch. Okay, finally, you have the AWS code pipeline, which is an orchestrator and works with all these different tools to provide an end-to-end CI/CD pipeline on AWS. Thank you. In this lecture, we are going to deploy our CloudFormation template using the AWS CI/CD pipeline. So mainly we're going to use AWS code commit, which is a code repository similar to Git. So you could either use GitHub or AWS code commit or Bitbucket. For our case, we're going to use AWS code commit. Then we're also going to use the code pipeline through which we are going to orchestrate the deployment process. Now this is the step-by-step guide we are going to use for deployment. So the first thing is we create a repo using the AWS code commit. Okay, I do a search for code commit. Okay, I click on create repository. Let's name it as a repository name. Let's call it as demo n17. Okay, and we'll just do a create. Okay, now what we can do is we can add a file. So whichever CloudFormation template that we need to deploy, we're going to add that file. So I click on add file, upload file. I click on choose file. So I've created a folder which has all the files. So for now, we're just going to create an S3 bucket using the CloudFormation template. So I select on this author name. You have to give some author name, give some mail ID, and you can give first commit. So I do a commit change. Okay, so this is our CloudFormation template. It's a very simple template which creates a bucket name with S3 bucket with this bucket name. So let me just go to the repository that we just created. So this is the repository we created, and now you will be able to see we have this S3 YAML file within this repository. Okay, so we completed the first step and then we uploaded the CloudFormation template. Okay, and now as a third step, we have to create a code pipeline role. And this fourth step we need to follow is create a CloudFormation role. So which will give AWS CloudFormation have the right access to be able to create services. So like in this case, if you're creating S3, EC2, etc., that permission the CloudFormation role should have to create those services. So we need to create these two services, these two IAM roles, the code pipeline role and CloudFormation role. So let's do that. Okay, I'm on the IAM console. So let me go to the roles, create role. You can see here AWS does not offer code pipeline role, so that's a little bit of a challenge. So what I will do is I have some content which would provide the inline role for the one we create for code pipeline, and I will share that with you. I've taken that role from the internet, so you can see, you won't be able to see the code pipeline. You can see code build deploy, but you cannot see code pipeline. Okay, so for now we'll just go with EC2 and then we'll modify it. I go to next, create a role. So we'll say is code pipeline role, and we'll name it as 1710. Okay, so we'll say code pipeline. Okay, so we'll let it be as it is. So we'll create a role. Okay, now you can see it's creating a pipe, the role. So it's created the role. Now what I'm going to do is I'm going to add a permission inline role. So create inline policy, and I have already noted down this policy, so I will just copy it from here. I will share this role with role details with you. So go to this JSON and get rid of this and just paste it here. Okay, so review policy. And just create the policy. Okay, so let's see if our role has been created. So let's say code pipeline, and this is the one we have. So the only thing we need to now further modify is a trust relationship. So here you can see the service is EC2 Amazon AWS. So we'll edit it and replace it with the code pipeline. So I've just highlighted it here. Okay, and make the edit here. Okay, so I'll just do update policy. Okay, now I think this role is good. The next role we need to create is for the CloudFormation to be able to create the services that it is looking to create. So in this particular case, we only have S3, but we're going to do it for S3 and EC2. So let me create a role. So I'll go to roles, create a role. And in this case, the AWS actually allows, so I can search for CloudFormation. So I do CloudFormation, and so I will say S3. So I should have full S3 access. So I'll select on this one, and then I will select EC2. Okay, so EC2 full access. Next. Okay, it has EC2 and S3 full access. So I have to give a role name. CloudFormation in 17. Okay, so create role. Create role. Okay, now I think it's already created both the roles. Okay, now let's look at the fifth step that we need to do. We created these two roles, the code pipeline role and the CloudFormation role. Now we're going to configure the pipeline and then deploy the CloudFormation. So let's search for code pipeline. Okay. And click on create pipeline. Let's give the pipeline name and 17. Okay, so we already have the existing service role, which is the code pipeline 1710 that we created. Okay, so we'll let everything remain as default. Click on next. Service provider, we have the AWS code commit where we had created a repo earlier. Okay, repo name is demo 1017, which is the only one we had created, if you remember here. So this is the one which we had created. Okay, so branch name is main. We only have one branch, and we'll use AWS code pipeline. Next, build provider. So build provider is usually used when you are trying to build a Java-based application or containers. In this case, we're not going to build anything, so we're going to skip this build stage. So deploy provider is AWS CloudFormation. Action mode, you can either use create or update stack, or you can use execute a change stack. So we'll just use create or update stack. Stack name, we can name it as demo s3 stack. You can give it any name. Artifact, source artifact, the file name is the file that we have uploaded here, which we are looking to execute. So let's go copy this and place it here. Okay, so now capabilities, we can just leave it. Role name is the CloudFormation role, IAM role that we created. So this is the one. Okay, everything else remains default. And let's do a create pipeline and see if it works. Okay, so let me go to CloudFormation and see the stack creation is in progress. If I click on demo stack and resources, you will see we'll have one demo bucket 0977 that is being created. You can see this S3 bucket has been created with the name we had in the CloudFormation, and this has also succeeded. Awesome, thank you. In the previous lecture, we deployed the CloudFormation template using the CI/CD pipeline. But the one challenge that we faced was that the bucket name or any other details, properties related to that service was hard coded. Now, what if we have to parameterize, or we have parameterized certain properties? How do we deploy that CloudFormation template which has a separate parameters which are not hard coded? Now let's take a look. So here we have the CloudFormation template where we're deploying the S3 bucket and EC2. And you can see we have multiple parameters, so S3 bucket name and EC2 parameter values, where we have the EC2 instance type, whether it's T2 micro, small or large. So how do we deploy this kind of a template? So what we typically do is we have two files where we have the CloudFormation template. So this is one. The second one is we create another file with all the parameters where we put in the values. So let's take a look. So what you can do is just copy all these values from here. So it basically needs to be a JSON file, and do a YAML to JSON. Okay, open this and just paste this here. These are all the parameters that you have, and then you remove all these values from here. Okay, and you copy this X and you hard code the values, or you, when you deploy, you put the exact values that you need, and you remove this. It's 3M007007. I'm going to put a unique name. Okay, so now I have the JSON with parameters. I'm not JSON. Okay, so I get this JSON file, so I just do a copy, and then I open this parameter file and then put the JSON value. So here, like I have just done. Okay, now we'll use these two files and deploy using the CI/CD pipeline. Okay, so we'll follow the same guide. So we'll create a repo using the AWS code commit. Then we'll upload the two files. One is the CloudFormation and the configuration file. We'll use the role, the two roles that we created in the previous lecture, and then we'll configure the pipeline and then finally deploy. Okay, so I'm on the code commit repository. So I'll create a repository. Let's call it demo 0001 and create. Okay, so we'll upload the files. Upload file. Choose file. So we'll use the CloudFormation one, and we have to give the author name. Let me copy this and let's do first commit. Okay, so we'll upload the second file now. So this is our CloudFormation template file. Upload file. So we have the parameters file. Author name is Rahul again. Okay, second commit. Do a commit change. Okay, awesome. I think we have both the files now within the repo. Okay, now we'll go to the code pipeline and configure. So create pipeline name, demo with parameters. Okay, existing role. So we already have the code pipeline role, so which we created in the last lecture. So we'll just leave it as default. Service provider is AWS code commit, and repo we just created this demo 001 branch, let it be main. So we have the code pipeline to detect the options. Next, build provider. So we're not doing any build, we're not doing any Java build or ECR container, etc. So we'll just skip this stage. Skip. Okay, deployer provider is our deployer is our CloudFormation. Action mode, create our update stack. Stack name, let's call it as demo 011 stack. Okay, now we have the artifact name, source artifact. So file name, let's go to the CloudFormation, and this is our file name. So let's copy this and paste it here. Okay, now use the configuration file. You can see this option is disabled, so we'll go and enable this source artifact, and this is where we're going to put the parameters file. Okay, you can leave it as it is. The role, we have the CloudFormation that we created earlier. Next. Okay, so everything looks good. Let's see if it works. Still working. Okay, so the first phase has succeeded. Let me go to AWS CloudFormation. Let's see if anything is there. Okay, so it is coming up. This is our stack name, and these are our resources. Okay, I think it's already almost come up. So you have the S3 bucket hello that we had here, and then you have the EC2 instance coming up as well. Okay, you have the EC2 instance initializing. So you had the instance type micro that we had provided, and you also had the S3 bucket, and you can see the file name we had hard coded here in the parameters file. So it's the same name. Okay, awesome. I think it's create complete. So it's created all the services. And if I go back to the pipeline, you can see you have the deploy that succeeded as well. So I think this is pretty much it. Thank you very much. Okay, from the template anatomy perspective, we have looked at these 6 sections till now. In this section, we are going to look at something known as mappings. So as per AWS documentation, mapping is the optional mapping section, matches a key to the corresponding set of named values. So where do we use the mapping section? Now, say earlier what we had done was, say we're trying to create an EC2 instance, and the value it picks for image ID, we provided a certain AMI value, and then it runs in the US East region, it picks that value and creates the EC2 instance. But now imagine you're a global organization and your cloud engineering team has created a CloudFormation template, and you have the team in the US East region which uses this template and substitute the AMI value, and you're able to create the EC2 instance. Now suppose there is a different team in Mumbai region and it is using the same CloudFormation template. But when it tries to create an EC2 instance with that AMI ID, it is not going to work because each region has a different AMI ID. So what you would ideally want your CloudFormation to be able to do is that you define certain set of, say, AMIs which any application team can use, and you define those, and then each region you define the set of AMI IDs that those teams can use. And then when you run the CloudFormation template in any region, it picks the values corresponding and which are applicable in that region. So in the Mumbai region, it only picks AMI IDs which are relevant in that region. In US East, it picks values which are relevant in US East. Or if you run it in any other AWS region, it picks only those AMI IDs. So it allows you to parameterize templates. Now let's take a look. So this is the syntax for the mapping section. First, you have the keyword mappings. Then below that, you have the logical ID or logical name that you provide. You can provide it anything that makes sense in your template. So here, what we are trying to do is we are trying to define the AMI's IDs that will be applicable to each region. So you can give it a name. So here, it's been given a name, a region map, because it's trying to map the AMIs to a particular region. So that's the first one. Below that, then you have the US East, you define the region, and then you provide a key value pair. So it's US region, you define the key and the value of the MID. So you can have multiple key values within the region. Then say if you're defining it for US West, you can define the key and you define the value. For another region, you define the key and you define the value. So when you run this template in a different region, it will pick only the values that are corresponding and relevant to that region. Okay, so hope it's clear. Now, when we use the mapping section, there are three things we need to keep in mind. So the first one we already discussed, which is the mapping section. So you define the mapping section here. So here you have defined multiple key values pair for each region. So you can see here. Now the question is, when we are trying to create a resource, so here we are trying to create a resource and EC2 instance, how does it pick the value? How do you define here the corresponding value for image ID? If you remember, when we were using the resources, we'll do the ref and then give the logical ID of the parameter section, right? But here it is trying to pick up the value from the mapping section. So what you do is you define the property here, image ID, and then you ask it to find the value from find in map. So find in map is a intrinsic function. So what is the syntax for find in map? You can see it here. Okay, so you define the find in map keyword, and then you do the first level is map name. So this is the map name, so region map. You provide what is the map name. There's a logical ID from the mapping section. Then you provide the top level key. Top level key would be which region it is going to run in, and then you provide the second level key. So here you can see there are two keys. This is the first and this is the second. You have the map name here, then you have the top level key, which is the region, and then you have the second level key. So you pick one of these. Okay, now let's take a look here. So you have the image ID and use the intrinsic function find in map. The first thing you do is you look at the region map. So you says it's going to pick from here. The second thing is ref AWS region. So we'll just talk about what the AWS region means, what with this particular means. So it's a pseudo parameter, and we'll talk about it. The third thing is when you look at the second level key. The second level key is HMV64. You suppose you are running it in US East, and when you pick this value HMV64, this is the MID it is going to take. Now the third thing we are trying to discuss is what is this pseudo parameter or AWS region. Okay, let me just go to the documentation and show you. Okay, I will copy the link here. See here, it's taken us to the pseudo parameter page. So what's a pseudo parameter? Pseudo parameters are parameters that are defined by AWS CloudFormation. You don't need to declare them in your template. So say in case of parameters, when you're trying to assign certain value based on, if you remember for the parameter section, so you define those parameters. But in case of pseudo parameters, they are AWS defined and you don't need to declare them in your template. So what does this mean? So let me just show you. These are some of the pseudo parameters. So you have the AWS account ID. If you run this one, then it will give you the account ID in which that particular template is running. Similarly, you can have AWS notifications, ARNs, and you have the AWS region returns a string representing the region in which encompassing resource is created, such as US West. Okay, and how do we use it? So here you can see this is how you use it. You use the ref and then provide AWS region. So like in this case, the second level key, when you do ref AWS region, it will automatically see which region you are running that stack from. So when you upload this file on the CloudFormation service at runtime, it will read which region it is being run from, and then it will supply that value. So if you're running it from, if you're running the template in the CloudFormation service in US East, it will give pass on the value corresponding to the US East. If you are running it from EU West, it will pass on the value from the corresponding region. Okay, so those are three things you need to keep in mind. First, you define the mapping section and you provide the map name, which is like region map, top level key, which is the US East, and then you provide the second level key. Then using the find in map in the resource that you are trying to create, you have three things. You put it find in map, then you put the map name, then you put the top level key and your second level key. So in the map name, you provide the region map, then you provide the region from where it's going to pick up the value, and then you provide the second level key. So let's do a quick hands-on on this. So I've just opened the CloudFormation template, which we had created earlier for S3 and EC2 with parameters. So I'm just going to do a save mapping. Okay, I'll save this lecture. Okay, so what we're going to do is we're going to create EC2 instance and we'll provide it two AMI values in two different regions, and then we'll allow it, say, in US East and one more region. So in US East, we'll provide it two AMI IDs. If it's test, then it picks some value. If it is prod, then it picks some other AMI ID, and then we run the same CloudFormation template in a different region, and again we do test and prod. Okay, so the first thing is let's copy the template anatomy. Let's go to template anatomy and copy from there. Okay, here is our CloudFormation template anatomy. The only new thing we are going to add is mappings. So we'll just copy this mappings. You can see it's at the same level as the resource. So I go ahead and so mapping section, and let's name the map name as, let's call it EC2 to region map. Okay, and let's give some space. The next one is we have to put the region. So let me just go here, and so US East 1. So let's take one as US East 1. So call it as US East dash 1, and give a colon. Okay, so if you don't know the syntax, you can just go to and check it from here. Okay, so this is the region map, and this is the top level key and the second level key we have to provide. Okay, let's call it as, if it is test, then we'll give it some AMI ID. Okay, so like here we had HMV64, this is the AMI ID. So let's go ahead to EC2 console and let's pick some AMI ID from here. Okay, so this is my AMI ID in the US East region. So I'll just paste it here. I just want to see if there are apostrophes we need to put. Yes, so maybe we can put it here, and I'll just put it here, and then we should say if we run it in prod, then this is the AMI ID it should pick. Let's see. Let's pick some other AMI ID. So this is the second one. So I just copy it from here and I just paste it here. Okay. Now let's look at a different region now. Let's select a different region here. Let's put it as US West 1. US West 1. So top level key is US West 1. Okay. So if you don't know how I'm getting these values, you can just go to this mapping section here, and this is what the mapping section is. So you have the mapping keyword, then you have the mappings as 0, 1. So the name we gave here, which is EC2 to region map, and then we provided the key 1, which is the US East 1, and then we provided the name value. Similarly, key 2, now the key 2 is US West 2, and I'll just copy this and I will change the AMI IDs because it's going to be different in this region. Okay, so I go to EC2 and then I am now in North Canopolis or forward experience. Okay, now I'll copy the AMI ID from here. So you can see the AMI ID is different for the same kind of instance in the region. It was 05, it's 18. And then the second one we're going to pick here. Okay, awesome. Let me just save this. So we have now 2 regions and we have different values from test and prod. Now the second thing we need to do is, if you saw here, 1, 2, 3, we provide the mapping section. Now under the resource, we need to substitute and provide find in map values. Okay, so I go to the EC2 instance, and in place of this image, which we had hard coded, so I'm going to find in map, Let me just copy this, and so that I just don't get any syntax errors. I will go here. Okay, I will just copy this one here, so that's just easier. I'm just copying the syntax for find in map. Okay, I will go here and find map name. So map name is EC2 to this region. Okay. The second one it has to pick up is, as we discussed here, it has to automatically pick up the region. So we'll use the pseudo parameter called as AWS region. So let me just. So what it will do is, as soon as I run it in any region, it will automatically pick up the AWS region. So let me just copy it from somewhere. Okay, I'll just copy it here. Okay, now we have to provide the key. So now we can see we had said, okay, first thing is it's going to look at the mapping section now because we have put the find in map. So it will go there and then it will see region, whichever region we're running the CloudFormation, it will go to that particular region. The third thing is, how does it now know from the second level key whether to use test or prod value, right? One thing we can do is we can provide some parameter here, like say environmental variable. Okay, variable, and we can just like, it's just a parameter, so we're just going to copy this syntax. Okay, and if you don't remember how I got this, look at the parameter section lecture. So this is a syntax for define the parameters. You define the logical ID. So this is what I have done, and then you have the type, and then you have the default value, and then you have the allowed values, and you have the description. Okay, so I need to move to a little left. Okay, I go here, and here we have two options, right? Test or prod. So we'll just provide those two. So you have the test, and then you have the prod. Okay. And I'll just put default as test. You can do anything, anyone which you want. I'll get rid of the description. Okay, now what is going to happen is that you will have, the user will have the option of selecting the environment variable. So if it selects test, then it will pick this MID. If it picks prod, then it will take this MID. Okay, and then here we define, we're going to provide the ref it is going to take from the environment type, right? So ref, let's see what was our environment variable. So I copy here and give some space. Okay, so now here you can see that it doesn't seem right. The logical ID and the type, there's a space, but here it's at the same level. So let me move this to a little right to the tab and remove. Okay, let's remove this extra spacing. Okay. Awesome. So the parameters, then we have the mapping section, then we have the resource section, and that's pretty much it. Let me do a save, and now we should be able to run this. So let me go to my CloudFormation template, and here's the CloudFormation create stack, load, choose file. Okay, so this is the one. Okay, so we are running it in North Virginia. Just giving some error. Line 11, column 14. Line 11, column 14. Okay. Okay, I think this should be in line with this. Here you can see type and default at the same level. So I just need to move back. Okay, hopefully it should work now. Let me do a save. Cancel this, choose. Okay. Okay, I think it works. So let me call it as EC2 S3 mappings, and here are the variables. Here are the parameters that we need to select. So we'll select E2 micro. Environment type, right? If you remember, we had put the environment type here, the environment variable, and I can choose test or prod. Then it will, and when we try to create the EC2 instance, it will take the value from this environment variable. So if I select test, we are running in the US East, so it should pick this. If I are in the prod, then this is the one it should pick. Okay, so I'll just test. And because we are also creating an S3 bucket, so let's just name that as well, although it's not relevant in this case. S3 0090. Okay, I'll just do next and next and create stack. Okay, now it should use the AMI ID. We use the test, right? So it should use, and we ran it in the US East. So it should pick this AMI ending with 76. Let's see. Okay, it's created the S3 bucket. Let me just click on this EC2 instance and just check whether it used the same AMI ID. Okay, I'll just click on this. Okay, here is the AMI ID. So 376, and you can see 376. So this is how it will automatically pick the, we didn't provide any details, but it picked based on the region. So now let's try and run it in other region and see if it works there as well. Okay, I will select the US West. Let's just check what is the one we provided. US West 1. Okay, so I'm in US West 1 now. So let me go to CloudFormation. Create stack, upload template, and this is the one. Okay, EC2 S390. Okay, I'm just giving some random date. So I'll pick T2 micro. Let's pick prod this time environment variable S3 Rahul 222. Okay, I'm just giving some random name. Okay, and let's run. Create stack. Okay, let's see what it does this time. So we gave the prod value and we gave US West, so it should run this AMID EC2 instance with this AMID 59D. Let's see. Okay, so it's saying invalid AMI ID when I write now. So let's take a quick look. Okay, so let's see. When I go to the US West one, I see that this is a valid AMI. So okay, so this is the one. So maybe I don't know if this is the reason. Let me just try and save this and run it again. Maybe that was the reason. So here in the North Virginia it's running, so it's complete. Now let me try and rerun it. Okay, so new resource, upload template, okay, mapping. Let's see if it works now. S3 EC2 okay. So we'll give it again prod and S3 and okay, some random values and let me run it. So now we can see that EC2 instance has got created, and let's now check the AMI ID for that. So the AMI ID should be this one ending with 59T. Okay, 59T. Okay, so here is the AMI ID with 59T. So you can see that it automatically pick up AMI in the US West region when we ran it in this particular North California. Thank you. Previously, in the CloudFormation template anatomy, we looked at 5 sections. In this one, we are going to look at the 6th section, which is the outputs. So outputs are basically declare output values that you can import into other stacks to create cross-stack references. So what does this mean? So there are basically 2 scenarios in which you can use outputs. The first scenario is, say you have created a CloudFormation stack and there are 50 or 60 stacks, and you say one of the resources that you have created S3 bucket. Now you want to use the name of the S3 bucket that's been created by the CloudFormation somewhere. Now what you might have to do is you will have to scroll through those 60 different resources that you have got created and then search for the S3 bucket name. The other option you have is that certain resources where you specifically need the name of that particular resource, you can just export those values. So it will be visible in the export section, and you can then easily copy and paste. The second use case is where you can use outputs is, if you look at a typical enterprise. Now say you have a credit card division in a bank that wants to push its workload to AWS Cloud. So what typically happens is there would be a cloud engineering team which would create a new AWS account, and then it will run some of its services like CloudFormation, maybe by networking team within the cloud engineering or cloud engineering itself, and they will create some baseline. So they'll create some VPCs, they'll create some subnets, they'll create some route tables, etc., depending on the requirement. And then you will also have a security team which runs certain baseline configuration, right? So once you create those VPCs, then you will have the application team, security card team, which will deploy their application. So they are not going to create the VPC every time. So they are just going to use the existing VPC CIDR blocks or subnet CIDR blocks. So that's where it can be useful. So what you do is, as a cloud engineering team, you create the VPC subnets and then just export all those CIDR blocks and values of VPCs and subnets, and those values then can be just imported by the application team, right? Okay, now hopefully it's made sense, but if it's not, that's fine. Let's look at it now. So here's an example. So the first thing, as part of the outputs, you have an export and you have an import. So here you can see I've just created a VPC, and you have the subnet and you have the VPC. Now you can export those values, you can output or export those values. So here I am exporting the value of the subnet. Here I am exporting the value of the VPC. And now say you are creating an EC2 instance, say the application is creating an EC2 instance, and you want that EC2 instance in a particular subnet that you have created here. So what you can do is you can export the logical name of that subnet and then just import it here and substitute the subnet value by the import function you have here, and the value will come from the export that you have done in a different template. So this way you can create a cross template stack. Okay, now we'll just quickly do some hands-on and see how this works. Just keep an eye on the syntax. Okay, so first thing is we create the file name. So new file and VPC subnet, let's just call it as output export. Let's name it as .yaml. Okay, so just create a file, and I'll just copy this whole thing from here, from the VPC EC2 S3 altogether file, and we'll just get rid of the other values other than the VPC and subnet. So I'll just get rid of this. I'll get rid of the S3 bucket, EC2. So we have the subnet and VPC here. I'll get rid of this. Okay. So now we just have the VPC and subnet here. Now let's see what is the syntax for export. So this is the link that I copied from the output section. So I'll just copy this YAML and let me just go here. Okay, and we'll just paste it here. Okay, now we have the output section, right? It's similar to resource or parameters at the same level. Now the second thing you can see here is we have to put the logical ID. So logical ID, let me just put it as VPC, let me just put it as VPC ID O as an output description, output the VPC value to return. So what is the value that it is going to return? So it's going to be the resource that is getting created, it logical ID for the resource, VPC resource that's getting created. So I'll just copy it here, and so the value is, so just put ref, and then we'll put the logical ID, and that we'll get from the resource section that is created. Okay, so now you have to do an export, and you have to give the name which you would like to export, and this export name, whichever CloudFormation template is going to import this is the name they're going to use. So VPC, let me call it VPC import. Okay, Now we'll create one more which will be for subnet. So this is for VPC. So need to follow a similar process. Subnet. Okay, output of VPC subnet ref, and we'll again use the values ref. So for subnet, the name was in the resource section was this. So I'll just copy this and paste here. Okay, so let me just substitute this value, and VPC is called subnet import. I'll do a save. Let's see what happens. Let's try and run this. Okay, I go to CloudFormation, create stack, choose a file, and this is the output. Okay, do next. We call it output export. Okay, so we have to give the values. VPC subnet, let's give 0/24. And let's do next. Next. Okay, create stack. Let's see what's going on. So you have the events, you have the resources, so you have the outputs, right? The output section we have created. So hopefully earlier it wouldn't show any outputs because we hadn't created in none. Now it should show. So you have the parameters, you have the two parameters that we entered, and you have the resources. So VPC has got created. Subnet is still in progress. Now let's see if there's any value on the outputs. Okay. Okay, both have got created. Now you can see we have both the values that are highlighted here. So the value, the logical ID that we had was VPC subnets O. See here, VPC subnet O and VPC subnet O, and then you have the VPC ID O, and then you have the export name VPC import and VPC subnet import. So that's what you can see here. So that's how you do the export in the outputs. Let's see now how these values can be imported by another CloudFormation template. Okay, now we'll do an import of these values in another CloudFormation template where we're going to create an EC2 instance, and subnet where EC2 instance would be placed would be taken from the export name from this particular CloudFormation template. Okay, so let me go here and let me save this as, okay, I'll go to the previous one. I will do, this is the one we had created, VPC EC2 S3 earlier in one of the earlier lectures. So I will do save as, and then I will do EC2 VPC import. Okay, I do a save, and now what I'll do is I'll get rid of all these values except the compute section. So I'll just get rid of these, and then network configuration I need to get rid of. Okay, so this is gone. So parameters will don't need the S3 bucket. We get rid of the VPC ID, we get rid of the subnet, and in the resource we only need EC2. So I'll get rid of everything else. Okay, now here we have to add another property which is called the subnet. So let's go to CloudFormation EC2 CloudFormation instance. Okay, here we are. You can see for YAML there's when we look at the EC2 instance creation, there should be some subnet value as well, ID, right? So I will just copy this, and what to add here is subnet ID. Okay, now before we import that value, that we had exported here, VPC subnet. Let's take a look at the syntax. So we can just do, you can see here in the documentation I have given this. So first was the export and now we have the import. So I'll just go and search this. So remember, there are, for outputs there are two things. One is the export, where you will have a CloudFormation that will export some values, and then you have the import, where another CloudFormation template is going to import those values. So here you can see function import value, and if you look at the documentation, this is what the function looks like. Function import value, shared value to import. It is a value that you're going to import from the name that you're going to import from other template, or simply you can write it like this. So I'll just copy this, and instead of string, I'm going to do this. Shared value to import is the name of the export value. So here there was the export name, we have given this. So I'm going to copy this, and I'm going to place it here. Let me just do a save. Let's see if it creates an EC2 instance in the same subnet. So let's run this CloudFormation. So remember, let's look at the resource. So this is my subnet ID. So the subnet ID should be 5B. And the other thing you need to remember is that you cannot delete this CloudFormation stack. If there is a dependency of the second CloudFormation template or the first, then you cannot delete that. Okay, now, so it should be in the 5B. Okay, now let's go to stack. Okay, upload template. Okay, so it should be something related to export. Or let me just check the name. So the name is import. Okay, so where is the import? Okay, here is the import. So I import this one and I do next. Okay, so I will say outputs import, and image ID, we have the compute, so I'll just keep it as default. Next. Okay, I'll just get rid of this. Next, stack. Okay, let's see what it does. So it's in the process of creating this EC2 instance. Okay, it's creating an EC2 instance. It should be pretty fast. So let's see if there's in the output. There's nothing. So one parameter that we had. Okay, still in the progress of creating. Okay, let's go to this EC2 instance and see what it's doing. Okay, so you can see it's creating this EC2 instance. Let's look at the subnet. What is the subnet it's using? Yeah, you can see the subnet here. So it's using 5B, and the export that we had was also 5B, right? So basically this is what it does. Now the create is also complete for this stack. So what we have done is we created the VPC and subnet in one CloudFormation template, and then we exported those values, you can see, and this is the export name. And then in this CloudFormation template, when we created the EC2 instance, we use that subnet as an import. Okay, so that's how you use export and import to create cross-stack references in an organization. Hope this was useful. Thank you. Okay, earlier we looked at template anatomy for CloudFormation and looked at the first 7 sections. Now we're going to look at the 8th section, which is the conditions. So as per AWS documentation, the optional condition section contains a statement that defines the circumstances under which entities are created or configured. So what this is essentially trying to say is that when you are using conditions, let's take the example of, say you have multiple environments. You have the test and you have the product environment. What you might want to do is, when you are looking to deploy this CloudFormation template in production environment, you might want some additional resource to be created, say S3 bucket or another EBS volume that would be attached to the EC2 instance. But when it's in the test environment, you want to keep the cost low. So you don't want additional EBS volumes or another S3 bucket that should be created. So what you can do is your cloud engineering team can create a CloudFormation based on which you will have certain resources, set of resources that are created in one environment and another set of additional resources that can be created, say, for a higher environment. So that's where the condition section can be used. Now let's take a quick look. So before we move on to the hands-on, let's take a quick look at the conditions and how they are used. So the first thing is that you are going to use it with parameter section and a resource section. Okay. Now say you want to create an EC2 instance, but you want an additional EBS volume to be attached when you run this in the production. And when you run it in the test, you just create EC2 instance with one EBS volume. The first thing you are going to do is in the parameter section, you are going to create some parameters. So here you can see we are creating the environment type and description is environment type. So we know about parameters. We had discussed them earlier. And then you have the default as test. So if user doesn't put any input, it's the test environment. And then what are the allowed values for this environment type parameter? You have the prod and test. So you have two options. Okay. The second thing you are going to create is the condition section. So in the condition section, what you will see is here is the syntax for the condition section. So you have the keyword conditions, then you provide the logical ID, whatever name makes sense in your CloudFormation template, and then you write the intrinsic function. So what is the intrinsic function here? So here are some of the intrinsic functions that you use along with the condition. So it is and, equal to, if, not, or. In this case, we are going to use equal. So if the condition matches, then this is what it should do. Okay, now let's get back to this section here. So first you write the keyword conditions, then next you write the logical ID. So here we have written create prod resources because we are creating an additional EBS volume if it is in the prod. Okay, but you can give the name as anything you want. Then you write the conditional intrinsic function. So here we are saying as equals to. So if the environment equals to prod, then execute this condition. So next you will see intrinsic function like equals. In this case here, this is how it will be structured. So it will have two values. The first, as you can see in this case here, the first value is environment type. So what it will do is once it starts executing it looks at the condition block, it will see what is the environment type. So you have the environment type parameter here. Okay, it looks at the environment type, and then we had two values, prod or test, and then it checks the second value. If the environment type the user has selected is prod, then it will execute the condition. If the user test selects the environment type as test, then this condition does not match. Here it is showing the condition, it does not match, then it will not execute the conditional block, right? Then if you go down, when you are trying to create the resources, you will see the condition here as well. Okay, on the EC2 attach volume. So this is my type. Then you will have this create prod resource, which was my condition here, the logical name for condition, create prod resource, right? You use the create prod resource, and then it will create a resource if this condition is prod and if it matches, right? So this is how you use the conditions. Let's do a quick hands-on. Okay, now I have opened the CloudFormation template which we have used earlier, where we created the EC2 and S3 along with resource and parameters. So you can see here we have the parameters where the user enters the S3 bucket name. Then you have the parameter where we select what is the instance type, and then we just have the resources which create the S3 bucket and EC2 instance. Okay, so what I'm going to do is I'm going to get rid of this S3 bucket parameter name for now. What we'll do is in this template, if the user selects environment type as test, then we'll just create the EC2 instance. If the user selects environment type as prod, then we'll create additionally an S3 bucket. The first thing I have to do is I have to create a parameter called, let's create a parameter type environment type. Okay, so I give the logical ID and then I just need to provide, okay, I'll just copy this itself, that might be quicker. So as I said, we are trying to create a parameter called environment type, which would provide us option to select either test environment or prod environment. Okay, string, so default is, let's just put it as test, and we'll put it allowed value as test, and the second one will provide as prod, and we'll just get rid of these two, and we will say that enter the environment type. Okay, great. So now we have the environment type. The next section we are going to create is, if you go to template anatomy, so here you can see conditions. Okay, so we'll just copy this from here and I go back, and it needs to be at the same level as resources. So what was the syntax? Let's just take a look. Here we have the condition, then we have the logic ID and intrinsic function. Okay, so I will just name the logical ID as prod resources, and then as you saw the syntax, it says it should be equal. So as you can see here, these are the intrinsic functions that we can use. So it's equals, not equal. Okay, next we have to define what condition it should meet. So let me give a space. So the first thing we're going to say is that it should look at, for this condition block to be executed, we need to define what condition should we meet, right? So the first thing is we have to look at the environment table. So we'll do ref and the parameter is env type. So it will look at the environment type, and if the user selects prod, just take a look at the syntax if it's not clear. So you can see here the function equals, and then you put the two values, which is the parameter type, and the second one is what is the value it should match. Okay, great. Now we know that EC2 instance should be created based on this, but what we also need to determine is when S3 bucket should be executed. So S3 bucket will be only executed if we select the environment type as prod. So we have to put a condition here. So we'll put a type, I will put a condition below the type. So the name of the condition, the logical ID of the condition is prod resources, and we just put the conditions before this. Okay, hopefully now it should work. Let me do a save. So what we'll do is, once we select test, it will just create the EC2 instance, but when we select the prod, it creates additionally an S3 bucket. So we'll just give the bucket a name, because we have removed the parameter for this S3 bucket. So let's just name it as Rahul 00987. Do a save. Okay, so I think everything looks good, so we can run this template. Just one minor update here. This should be condition, not conditions. Okay, and everything else looks okay. So I will just do the save, and I will run this. Create stack, and we'll just choose the file conditions. Okay, next, let's give it a stack name, conditions 0913, and let's just select this as prod. So when we select this prod, we should have EC2 instance and S3 created. If we select only test, then we will have only EC2 instance being created. Now let's test it out. Next. So let's see what's going on. So it's creating the S3 bucket and it's creating the EC2 instance. Okay, you can see now it's created both the S3 bucket and EC2 instance. You can see create complete. So you can just quickly go to this and go to this instance. So here you have the EC2 instance still coming up. It's running, and you also have the S3 bucket. Okay, next what we're going to do is we're going to delete this and we're going to just select the test in the parameter section as environment type, and let's see if only S3 bucket and EC2 gets created or only the EC2 instance gets created, right? Okay, let me just delete this stack. Okay, now let's run the stack again. So I'll just choose template and select this again, and let's call it as conditions 20913. Okay, so parameters we keep it as T2 macro. Now instead of the prod, we'll select only test environment type, and hopefully it will only create EC2 instance and not the S3 resource, because S3 resource creation was based on the condition that environment type is equal to prod is true. Okay, let's do next and keep everything as default. Okay, it says template has changed, that's fine. Create stack. Let's see what happens now. Okay, it's creating the EC2 instance, but we don't see the S3. Okay, we don't see the S3 still. Okay, we have the EC2 instance. Okay, awesome. Now it's created the EC2 instance, and you can see only EC2 instance has been created. Go to the you just have the, you don't have the S3. Earlier it created the S3 bucket as well. So hopefully it's clear to you now how we can use conditions based on certain criteria on what resource need to be created when a certain condition is met. Thank you very much. Okay, till now we looked at 8 sections within that template anatomy. Now we are going to look at the 9th section, which is the rules. Rules section validates a combination of parameters passed to a template during the stack creation or stack update. What it means is basically when the user inputs certain parameters, the rules is able to validate whether the combination of parameters are correct or not. To give you an example, say you have EC2 instance and you have two environments, test and production, and you want when the user selects test environment, he should be only able to select T2 small, and when he selects production environment, he should be able to only select T2 large. Now say what the user does is he selects the environment as test and then selects the from the parameter section selects the EC2 instance type as large. When you run this stack, it will give an error. It will not allow the user to do that. So that's what the rule section validates. It validates the combination of parameters as defined in the CloudFormation template. Okay, so the rule section has two parts. It has the rule condition, which determines when a rule will take into effect. Okay, so when you select the environment, then the rule condition, say for test, will kick in, and the assertion is it describes what the users can specify for a particular parameter. So when the user select test, it can only select the instance type as small, and when the user selects production, it can select the instance type only as large. So it will validate that combination. Okay, now let's take a quick look at template anatomy. So first you can see here you have the rule section. This is the rule section. Then you have rule 01, which is the logical ID. You can give any logical ID that makes sense to your template. Then the third thing you have is the rule condition, and you can see the indentation here, the rule, and then within the rule condition you provide what is the rule that you need to define. So here is the value 01, the rule 1, and then you have the assertion, what it is going to check based on the parameters defined. Similarly, you can define the another rule, the logical ID, then you will have the assertion. Now let's take a look at some of the interesting functions that you can use with rules. So you'll have and, contain, equal, if, not, or. So these are some of the conditions you have also used previously. Now let's take a look at one example here. So you have the rules keyword defined, and then you have the logical ID test instance type, like we had here. We had to provide the logical ID. So what this rule will do is when you select the test environment, it will allow you to pick even medium instance type, and when you select the prod environment, it will allow you to pick the large instance size. So this is what is going to validate. So now after you have put the logical ID, you put the rule condition. So you have the rule condition here, which is equals, right? The one we picked from here. Okay, now you have the parameters from the rule condition. So the first one is it will do a ref environment. So in the parameter section, it is going to check environment type. And if the environment type meets test, if the user has selected test, then this assertion will kick in. So you will again pick the function contains. So there are multiple functions that you can have as part of the rules. What contains basically does is it just validates if the condition is true or not. Similarly, you can have equal, not equal, or, so you can have all those conditions. Once it validates this is the test environment, then it would look at what is the instance type that you can use. So here you can use medium, right? And similarly, you have the second rule, which is production instance type, and here you use equals to. So it will look at the environment type in the parameters, and if it is equal to production, then it will allow only A1 large. So now let's take a quick hands-on. Okay, now let's take a look at a template I've just created. It's a very simple template. So let me just show you first all the sections. So you have the resource section here, and in the resource section, you're just creating EC2 instance. So you have the type EC2 instance, and I have provided the image ID here, and instance type, it is just picking from the parameter section. So you can see /ref instance type. Okay. Now let me go to the parameter section. In the parameter section, you have two parameters. You have the environment, and it allows two values, test and prod. Okay, so the user can enter the environment type. And the second one I have is the instance type. So this is where this resource takes the value from. So it can be either T2 micro or it can be T2 small. Okay, so that's the scenario we have. We create an EC2 instance. We have two environments, test and prod, and two instance types, T2 micro and T2 small. So what I want is that when I select the test, the user selects the test environment, it should be able to pick up T2 micro. When the user selects prod, it should be able to select T2 small. Okay, so the first thing I do is let's take a look at the PPT as well. Okay, so here I have the first thing from the anatomy perspective. I have to write the rules. So I will just go here and I write the rules, and then next we are going to look at the rule condition, and then we are going to look at the assertion. So first of all, we write the logical ID. So the logical ID is here. I've just written test instance type. Then we look at the rule condition. So rule condition would be equals. Okay. So what it will do is when it checks under the rule section, so you have the logical ID, then it will check the rules condition. So, and since it's equal, so what it will do is it will look at the ref environment, so which is the environment variable here. Okay, and then it will check what is the value of that environment variable. Say the user selects test out of the two values, test and prod. Now this rule condition matches, so the assertion will kick in. Okay, there are multiple functions for assertions. Let me just show you. So it's under here the rules. If you click on rules functions, so it will show you all different type of rule functions. So you have and, contains, member, equal, not, so pretty standard ones. So here is the one which we use, condition. So if you look at condition, a rule specifies entry function evaluates to true or false. Okay, so if it's true, then it will go ahead and let it execute the CloudFormation. If it's false, then it will give an error. Okay, now we have the keyword assertions here, and then assert. So this is based on the documentation. Let me just quickly show you. So you can see here you have the assertion, then you have the assert, and then you have the value. So now here we have the contains, and in the contains, what it will do is it will check whether the value, the test environment, is equal to T2 micro. If it is true, then it will execute the creation of the EC2 instance, and here is the ref instance type. That's a value it takes. And you can also put the description. Say for a test environment, I put here the instance type must be T2 micro, so the user can see that if it is something else, then it will fail. Similarly, we create another logical ID for prod, so it's prod instance type, then the rule condition equals, then it checks the environment, and if the value, then either it can be prod or test, so it checks the value. If it is prod, then this rule will kick in. And again we have the assertions, then we have the assert, which is a standard syntax, and then you provide the function, so contains, which evaluates whether it's true or not. So if he has selected the parameter t2 small, then it will initiate the creation of the resource. But if he chose say prod and t2 micro, this CloudFormation template is going to give an error. So let's now quickly test it out. So what we'll do is we'll first take the test environment and select T2 micro, and hopefully it should work. Then we'll select the test environment and take T2 small, and it should give us an error. Okay, I'm on my AWS console in the CloudFormation service. So I'll do a create service, choose a file, and I will choose the one which we had created with the rules. Okay, and I have two parameters where I have the test and prod, and then I have two instance types, T2 micro and T2 small. So my rule was when I select the test environment, I can only run T2 micro. When I select the prod environment, I can only run T2 small. Okay, so now here it's giving me error. Now let's first select T2 test, and if I select T2 micro, I should be able to create this EC2 instance. But when I select, let's select T2 small, and you can see this is giving me error due to the rule section that we have for a test environment. The instance type must be T2 micro, and this is I think the message that we were giving. Yeah, for test environment the instance type should be T2 micro. So this is the description message that users will get. Okay, now let's see with the prod. So when I select prod, T2 small, it's fine, that's what the rule that we had set. But if I go and do T2 micro production, the instance must be, so it gives a message error, right? So you cannot even if you try to create, it will give you an error. Okay, you can see it is giving me a rollback error, the parameter validation assertion error for production. Now the instance type must be T2 small, rollback requested by the user. But now if I try this same thing, the other instance type, it should work. So let's try that. We go back, create stack, and next rules test. So now we can say test, and small is giving error. Let's do T2 micro, so hopefully it should work. When we used the right one, which is the micro for test environment, it went ahead and created the resource. You can see here, so the resource has been created. Okay, so I'm going to delete this and also so as not to incur charges. Hopefully this was useful. Thank you.